Dear students, very good evening to all of you guys and welcome back again to BYJU'S Exam Prep. And guys, this is our part 2 of the structure analysis in which we will discuss the rest of the topic like our ILD part, arches and cables, moment distribution method, slope deflection method, matrix method. So these are the points which is still remaining and we have to discuss these topic guys in this particular marathon. Okay, so come fast and join the session, and before starting it guys, or before going further, please let me know audio and video is clear or not. Okay, and kindly share this session to other student also so that they can join over here, and ultimately all of you will get the benefit of this particular session. Okay, so please write down guys, audio and video is perfect or not. Ashish, very good evening guys, come fast and join the session. So quickly come and join the session guys, and please let me know audio and video is perfect or not. Please write down guys in the chat box. Thank you so much Ashish, thank you so much. Thank you so much. So those students who are watching this video as a first time and they are coming here as a first time also guys, let me tell you about myself. My name is Krishna Yadav and I'm teaching from last 9+ year guys, and generally my subjects are environmental engineering, structure, RCC and engineering mechanics. So these are the major subjects which I teach usually. Okay, so guys, as you know that this is our schedule. Vinod, thank you so much. Okay, this is our schedule as you can see here guys, right? So right now we are discussing the structure part, which is very important, and this is the structure part 2 basically. Okay, now guys, I think we have already covered the indeterminacy portion, stability of the structure, analysis of determinate truss. So these are the points which we have discussed, like method of structure analysis. So these are the chapter which we have already done in the part 1. Now what we have to discuss over here guys, that is basically the Three-hinge method. I think we have discussed it little bit, but guys, we'll start it again from the zero. Okay. Jai Bajrangbali sir, I am good. Swapnil, I hope you are also good. LKR, good evening. Sir, free कंटेंट सच में सही रहते हैं? रोहित, सही रहते हैं, ऐसा नहीं है कि फ्री सही में नहीं, अच्छे नहीं रहते हैं, बुरे नहीं रहते हैं, है ना। पहली बात ये होती है जो भी आपको कंटेंट दिया जा रहा है दैट इज अप टू द मार्क एंड अप टू द योर गेट एग्जामिनेशन, एंड ऑल दीज थिंग्स आर गिवन सो दैट यू कैन रिवाइज योर चैप्टर इन अ वेरी शॉर्ट ड्यूरेशन एज वेल एज you are able to understand what are the major points which you have to remember for a particular subject, right? So all these contents are no doubt very helpful for you in your examination. I'm good, LK. Now I'm good. Thank you so much. Now I'm good. Okay. So let's start the session guys. Let's start the session. We'll not waste the time. Let's start the session. So basically guys, as you know that in the last lecture we have discussed, there are basically two type of method of structure analysis. One is basically your approximate method of analysis and the second one is exact method of analysis. We know that guys, approximate method of analysis like portal frame method, cantilever method. So these are methods which is not useful for our GATE examination. That's why we are not discussing such type of content. But if we talk about the exact method, in exact method we have two portion. One is force method and second is displacement method or stiffness method, and these two methods are very important for our GATE examination. So in our force method, the major unknowns are redundant reaction. What is redundant reaction? Redundant reaction are those reaction which we are not able to find out by using static equilibrium equation alone. That means we need certain compatibility equation to find out the values of these type of reactions. So let me give you very simple example. So as you know that guys, let us suppose if we have two linear equation, x plus y is equal to 20, 2x plus y is equal to 30. If we solve these two equation, right, then we are able to get the values of x and y easily, right? So such type of condition is basically determinate condition. But if we talk about like there are two equation again guys, x plus y plus z is equal to 20 and 2x plus y plus 2z is equal to 40. So in such condition, one of the variable we are not able to find out by using these two equation alone. And that is the reason we need third equation. And such type of equation we have to develop by using compatibility conditions, right? Tiksha, very good evening. Girish, very good evening. Now I'm good, Prashant. Thank you so much. Okay. So as you know that guys, the strain energy method is our force method. It is basically our force method. This one is force method. So as we have discussed already guys, if you have any kind of structure, so on that particular structure, certain action will be there in the form of external loading, or it may be in the form of external change in environment like temperature change and etc. So that is basically our action part. So if you have certain action, now on this particular structure, you may get some response, and that response may be in the form of internal reaction, external support reaction, and slope and deflection value. Getting a point? So these are nothing as basically our response of the structure. Good evening, Arun. Good evening, Prince. So guys, there are basically three type of response which we get. One is external reaction that we have to find. Internal reaction, this is also we have to find, like what is basically shear force, what is basically bending moment, and slope and deflection value, right? So this is basically the response of the structure when we have certain action on the particular type of structure, right? So let's use, मैं भी अच्छा हूँ अरुण, आप भी अच्छे होंगे उम्मीद करता हूँ. So let's understand guys the strain energy method, right? So let me show you some examples so that you can relate it very easily. So you know that guys, in our previous session of structure analysis part 1, we have discussed how to find out the static indeterminacy. So I will ask you a very simple question. Please let me know guys, what is the static indeterminacy of this particular structure? Please let me know the answer guys very quickly guys in the chat box. This is a structure which is given to us, and let us consider a general loading is there. That means an inclined load is there. Please let me know what is the value of ds. What is the value of ds? This is A, this is B. Tell me guys quickly. What is the value of ds? Zero? No, Prince. It should not be zero. Guys, I'm asking ds. That means static indeterminacy. Prashant 1. Guys, it is a general loading. If it is general loading, you have to develop all the external support reaction like this. At this support, we have 3 reaction, and at this one, we have 1 reaction. That means in this particular case, can I write here guys, RE is equal to how much? RE is equal to 4. So can I write here RE is equal to 4, then DSE is equal to RE minus 3. And the value of RE is equal to 4. 4 minus 3, that should be equal to 1. But what about DSI? We know that guys, this is the open structure. It is not a closed structure. There is no closed loop. We can write here DSI is equal to 0. So ultimately, this structure will have ds is equal to 1. Getting a point? That means the total static indeterminacy is equal to how much? 1. So how many compatibility equations are required? Guys, in this case, only one reaction is there which we are not able to solve by using static equilibrium equation alone. And that is the reason we need to use the compatibility equation. We need to use compatibility equation, right? So how many compatibility equation are required? So number of compatibility equation required is equal to the value of ds. And how much ds we have? 1. So only one compatibility equation is required in this case. If we know this compatibility equation, we are able to solve our problem and get the answer. Very simple. Getting a point? Now the question is, sir, what is compatibility equation and how we can write it down? That is another question. So let's understand guys how we can write it. What is compatibility equation? So compatibility equation is nothing as it is the relation between the force and displacement. Simple. What is compatibility? Compatibility is nothing as it is the relation between the force and displacement. So let's understand in this particular case guys how we can write it down. Let us suppose this reaction is VA. This reaction is VA. This reaction is HA. This reaction is MA. And what is this? This is basically VB. Now let us consider one of the reaction is redundant reaction, right? So let us consider VB is redundant reaction. What is redundant reaction? Those reaction which we are not able to solve by using a static equilibrium equation alone, right? So in this case, let us consider VB is equal to our redundant reaction. So do you remember guys, as per Castigliano's second theorem, as per Castigliano's second theorem, we are able to write down the compatibility equation as per Castigliano's second theorem. As per Castigliano's second theorem, we can write here guys, first you have to find out the total strain energy of the structure, total strain energy of structure. First you have to find this, then take the first partial derivative of it with respect to any force or any reaction in which direction you have to find out the displacement, right? So let us consider, if I want to find out the displacement in any direction of in any force direction, so I have to take the first partial derivative of it with respect to the F, right? And it should be equal to what? It should be equal to delta F. But guys, in our case, we are taking the first partial derivative with respect to reaction. So in the direction of reaction, the value of displacement is always known to us. And if it is known to us, then we can write it 0. Getting a point? So guys, in this particular case, we need to write del ut by del r, and it should be equal to how much? It should be equal to delta r. But in the direction of our reaction r, what is the value of displacement? And that you already know, right? And it is equal to how much? It is equal to 0. That's why guys, we are writing this compatibility equation. Del ut by del r is equal to 0. And this is the equation which we have to use to find out our answer. Getting a point? So in this way, we can develop the compatibility equation easily. I think all of you are able to understand this condition. Yes or no, please write down in the chat box. Then we'll use some example to understand it. Crystal clear or not guys? Please let me know. Very nice. So let's solve some question to understand the concept. Okay. So let's solve with basic one. Let us suppose guys, this is a structure which is given to us, right? And let us suppose a loading is applied over here whose value is equal to P. Now just we need to find out what is the total strain energy which is stored in this particular structure, right? What is the total strain energy? So you know that guys, the strain energy will depend upon the internal reaction. What are the various internal reactions which we have in the structure? So you know that guys, in case of rigid jointed structure, there are basically three type of internal reaction. Axial force, shear force, and bending moment. But what happened guys, the 95 to 97% of the total strain energy is due to flexure part only, or you can say that due to bending moment only. And the strain energy due to axial force and shear force can be neglected. And that is the reason guys, you have to consider at the time of analysis, we will write here, at the time of analysis, we will consider the total strain energy is a function of what? Bending moment only. We will ignore the strain energy due to axial force and the shear force. Getting a point? Now just imagine guys, in this particular case, let us suppose if we have to find out the total strain energy and the deflection of this particular point B. Let us suppose these are the two things which we have to do right now. Okay, so let's understand how we can do it. So let us take a distance x from point B and take an element. Take an element whose length is equal to how much? Whose length is equal to dx. Whose length is equal to dx. Now I will break it so that you can understand it. Okay, so this is our element basically guys, whose length is equal to how much? Whose length is equal to dx. This is our value P. Then we have a moment which is basically P into X, correct? This is P into X. Now the same moment is to be applicable over here also. The same moment will applicable over here also, which is P into X. Now tell me guys, this P into X will be hogging or sagging? It will be hogging. That means negative on the top, or you can say that tension at the top. Due to that reason, we'll consider this is a hogging moment for this particular element. Clear? So guys, we can write here mxx is equal to minus px. and we can vary the value of x from 0 to L. 0 to L. Okay, sir. So let's calculate what is the value of total strain energy, how we can find it out. So total strain energy is equal to integration 0 to L mxx square dx upon 2EI. This is the general formula which we have to use. Now let's put the value of mxx, how much it is. So total strain energy is equal to integration 0 to L. This is minus px. So we'll write minus px whole square dx upon 2EI. Now let's do the integration and then we will put the limit. So it is 0, this is L. So guys, this value will become p square x square dx divided by 2EI, and we have to integrate it right now. Okay. Now I will remove the integration sign after integrating it. So what we are getting exactly, p square x cube divided by 6. 3 into 2, 6. 6EI. And the limit is 0 to L. So what is our total strain energy for the structure? In this way you can find it out, right? So P square L cube divided by 6Ci. So this is the value of total strain energy which we are getting in the structure. Are you able to understand how to find out the total strain energy in a particular structure, right? But guys, let us suppose if I want to find out the displacement of joint B in the vertical direction, so I need to take the derivative of it. So let's take the derivative of it. So as per Castigliano's second theorem, okay, as per Castigliano's second theorem, you have to take the first partial derivative with respect to P so that you will get the displacement in the direction of P itself. So it will become 2P L cube divided by 6Ci. Kindly cancel this, it will become 3, and this is nothing as our displacement in the direction of B or in the direction of P itself, right? Which is PL cube by 3I. Getting a point? PL cube by 3I. Yes or no? Please write down in the chat box. Please write down in the chat box. Crystal clear to all of you how to calculate the strain energy, how to calculate the displacement by using Castigliano's theorem. Just you have to revise it, right? No doubt if you have a lengthy problem, guys, then you have to apply the same approach, but it will take time to solve it, right? But we are just revising the concept so that we are able to recall the things very easily. Okay. Now guys, I think all of you are able to understand what is basically the strain energy concept. Okay. Now let's understand the next thing, which is basically our MDM method. Now it is very important. You can expect a single mark question from the strain energy method. Why? Because guys, usually they just want to ask the value of displacement, what should be the value of displacement, or what should be the strain energy which is stored in case of truss member. Let me explain that particular part also. So do you remember the formula? The strain energy due to axial force. So you already know that, guys, how to find out the force in case of truss. So usually they can ask what should be the total strain energy which is stored in this particular truss or in this particular member, how you can count it or how you can calculate it. So total strain energy will be equal to what? Summation I is equal to 1 to I is equal to N P square L I upon 2A. This is the formula by which you can calculate the strain energy which is stored due to the axial force. Clear? Clear? Video not visible, sir. Why it is so? I don't know. All of you are facing the same problem, or it is Vinod, Swapnil, Prashant, Girish? All of you are facing the same problem, or it is just no? Okay. So Vinod, what you can do, just kindly refresh the video. You are able to join it again. Okay. So now I think all of you are able to understand, guys, what is basically the strain energy method. Very simple. Just we have revised the smaller concepts, right? These are the concepts which you have to remember. Clear? Okay. Now let's understand the next part, which is basically the moment distribution method, MDM method, which is very, very important, guys. I will tell you a lot of things in this particular chapter. Okay. MDM method. No doubt this method is what? This method is our displacement method. This method is basically displacement method. From this chapter, you can expect a lot of question, guys, in the examination, right? Displacement method. Displacement method. And every year they just plan a single question at least from this approach. Okay, that's why it is very important. So this is basically a displacement method. But guys, the question is, what are the important things which you have to remember? Let me explain it. Okay, so please remember this particular point. What is basically stiffness? What do you mean by stiffness? What do you mean by flexibility? What is flexibility? Later on we will discuss it. Right now just we will discuss the stiffness part. Okay, right. Stiffness and rotational stiffness. Rotational stiffness, how you can find it out, what are the values that we have to discuss, and very, very important part. Getting a point? Second thing, stiffness, rotational stiffness. Okay, I will write it down first, then we'll see the slides. Then different sway condition and carryover moment, carryover factor. Carryover moment and carryover factor. Carryover factor. Next one is different sway condition. Distribution factor. Distribution factor. Distribution theorem. Distribution factor, distribution theorem. Fixed and moment values. Fixed and moment values. Right? Some of the values I will tell you over here, guys, which you have to remember and which is very, very common, right? Then how to solve the problem by using your MDM method only, right? How to solve the problem by MDM. Okay. So these are the things which we have to discuss mainly, guys, in this particular chapter. If we are able to cover it, that means a certain part of your slope deflection method will also get covered over here also, right? Because we have some common fundamental, which is basically an MDM method also and slope deflection method also. So let's start with the stiffness part. Okay. Now the question is, sir, what is basically stiffness? Okay. First I will explain the stiffness, then I will hide myself. Okay. So that you can see the slide properly. Okay. First I will discuss the stiffness part. Now what is stiffness? Guys, give your 100% focus to understand this portion. Very important. What is stiffness? It is nothing as the force required to give unit displacement is known as stiffness. Very simple definition. You know that, guys, let us suppose if we have a spring and right now the spring is not expanded, or you can say that unexpanded in condition. Now let us suppose, guys, if you have applied certain force F, now due to that reason, what will happen? The spring will get expand and it will change its location. Okay. So let us suppose this is the length up to which it will get expanded, right? So let us consider the change in length is equal to how much? Change in length is equal to x. Clear? So how we can write the stiffness? It is very simple. Stiffness multiplied by displacement is equal to force. You can write here, guys, F is equal to what? K into x. So what is our definition? It is the force required to give unit displacement. So what should be the amount of force so that displacement is equal to 1? So F is equal to how much? It should be equal to K, and this is nothing as our stiffness. So for 1 unit of displacement, this much amount of force is required, which is equal to K basically. So if you have X amount of displacement, then what should be the force? It is very easy, K into X. थोड़ा साइज इंक्रीज, आप बहुत स्मॉल साइज में लिखते हैं सर. ओके ओके, मैं थोड़ा साइज बड़ा कर देता हूँ फॉन्ट का. नो प्रॉब्लम अरुण. ओके, सो टेल मी गाइस, in this particular case, can I say that if x is equal to 1, right, that means for 1 unit of displacement, what should be the force which is required? It is equal to K. So if you have X amount of displacement, then what should be the force? It is equal to K into X. Simple. So this is nothing as our stiffness. But such type of definition is not useful in case of structure part. Why? Because we are dealing with the beams, columns and etc. So guys, in our case, we need to use a new term which is known as rotational stiffness, not a stiffness, right? Rotational stiffness. Now the question is, what is rotational stiffness? Let's understand it. But before that guys, let me hide myself so that I can write over there. Okay. Now guys, the question is, what is rotational stiffness? In our structure part, we need to understand this. So it is nothing as it is the moment required to give unit rotation at the near end. Now the question is, sir, what is near end? What is far end? Let's understand it guys by using one example. So let us suppose this end is hinge, or either you can consider roller also, and this one is fixed. Now let us consider guys, I'm trying to apply a certain moment over here, right? This is my applied moment. Please understand this. This is M. Please let me know, Arun, now font size is perfect. This is basically applied moment. This one is applied moment. Getting a point? This one is applied moment, which you have applied. Let us consider this support is hinge or roller where we have applied the moment, and such type of support or such type of location is known as near end, where you have applied it. This one is near end, where you have applied the moment. Getting a point? Okay. Now guys, this is our far end, where we will get certain carryover moment, right? So this is basically our far end, which is in front of near end, right? So this one is far end. So the certain moment you may feel at this particular location. So such type of moment is known as carryover moment. Why it is carryover? Because we have applied certain moment at the near end. Due to that reason, we may have certain type of reaction which can be developed at the far end, and such type of moment is known as carryover moment. Carryover moment. Getting a point? Now guys, if you apply certain moment, what will happen? The beam is trying to deflect in this way. The beam will try to deflect in this way. Getting a point? The beam will try to deflect in this way. If the deflection is like this, then tell me guys, this is the rotation which is caused at the near end, and the rotation at the far end is 0 right now. Okay. So this is the rotation which is caused at the near end. So how much moment is to be applied so that this rotation should be equal to 1? That is to be known as rotational stiffness. Getting a point or not? How much amount of moment you have to apply so that the theta is equal to 1 at the near end? That is known as rotational stiffness. So guys, in place of F, we have to write M. In place of X, we have to write theta. In place of K, we have to write K only. So our formula will remain same. Just you have to interchange the components. So you can write here M is equal to K into theta. So what is the value of moment so that the rotation will be equal to 1 unit, right? So that is nothing as, that is basically our rotational stiffness. Are you able to understand? All of you guys, please write down in the chat box. Crystal clear to all of you or not? Please write down in the chat box guys. Okay, very nice Ashish, very nice Arun, very nice Grish, Elkea, Swapnil, good, good, very good. Prashant, very good. Now guys, let's understand what are the values which we have to remember as per our examination, right? Let's understand it. So let us suppose if far end is fixed. Now you know that what is far end, what is near end. Let me come back. So please write down guys quickly what are the values. I'm just also writing. This is hinge. This is fixed. If far end is fixed, then what should be the rotational stiffness? This is A, this is B. And where we have writing the value of stiffness, let me show you that also guys. The value of stiffness from A to B is equal to how much? Do you remember this? 4 EI by L. From A to B, it is 4 EI by L, not from B to A. Getting a point? It is not from B to A. It is basically A to B. 4 EI by L, right? When far end is fixed. Now the question is, sir, when we have a near end as a B, let us suppose if you want to find out the value of stiffness from B to A, then in that case, what is the stiffness? Anyone who can tell me? If you want to calculate the stiffness from B to A, then what is the value? B to A, what is the value of stiffness? Any one of you? 2 EI by L. No guys, no. Please remember our definition. Hi Amal. Please remember our definition. What is our definition? Rotational stiffness is nothing as it is the moment required at the near end so that we can develop unit rotation at the near end, right? How much amount of moment is required so that you can give the unit rotation at the near end? That is our concept. But tell me guys, in this particular case, what is the value of KBA? It should not be equal to 2 EI by L. Why? Let me explain. It should not be negative. I'm good. It should not be negative. Let me show you that. So guys, as per our definition, if you want to find out the stiffness from B to A, you need to apply the moment over here. Correct? You need to apply the moment over here. Yes or no? Okay, let us suppose M is applied moment. Now tell me guys, what is the rotation at this particular point? What is the rotation at this particular point, which can be caused at support B? Tell me guys, how much it is? No Ashish, your answer is also wrong. This is your near end right now. If you want to find out the stiffness, then this one is your near end. What is the value of theta? It should be 0. It should be 0. In this case, can I say that this is my near end where we are applying the moment? This is our applied moment. Not possible. B is fixed. Moment applied at B will not give any kind of bending. Yes, definitely. That's why I'm explaining this particular point. Please understand, if you apply a certain moment at fixed support, so definitely you may have theta is equal to how much? It should be equal to 0. If theta is 0, then what is our formula? M is equal to K into theta. If theta is already 0, which is known to us, so we can write here K is equal to M by theta. And M by theta, theta means 0. If theta is 0, then K is equal to how much? Infinity. Now you are able to understand guys. Usually whatever value you are writing, like 4 EI by L, 5 EI means 3 EI by L and etc. So it should be written with respect to that near end, not with respect to the beam, right? At this particular means in this particular beam at support A, we have this particular value of stiffness, which is 4 EI by L. But at this particular junction, guys, if you want to find out what is the stiffness, it should be infinity. Getting a point or not? Are you able to understand? So that's why, guys, please remember the stiffness of the beam at the near end is 4 EI by L. This is not the stiffness of a beam. This is basically stiffness of this AB beam at support A. Getting a point or not? This is the major point which you have to remember. Crystal clear? Very nice. Superb. Now guys, let us consider when the far end is roller or hinge. So let us suppose this is our hinge and the far end is roller, or either we will consider opposite situation. This one is hinge and this one is roller. One and the same case, right? Let us suppose this end is A, this end is B. This end is A, this end is B. So this is our moment M which we have applied. This is moment M which we have applied. Then what is the stiffness from A to B? It is equal to 3 EI by L. 3 EI by L. it is equal to 3I by L. Please remember this. Now guys, if I ask you what is the stiffness from B to A, any one of you who can tell me the answer? What is the stiffness from B to A? Please write down in the chat box. No, Shiva, we have to complete it. I think after MDM, we will complete the slope deflection method. Then we have cable and arches. Then we'll start ILD part. And in the last, stiffness matrix and the flexibility matrix method. The value will remain same. If you write KBA or KAB, it should remain same. It should remain same. It should remain same. Very nice. Next condition, when the far end is free. When far end is free, what is the value of stiffness? When the far end is free. Now guys, if it is free, then this particular support, or at this particular support, beam can rotate infinitely. That means if you applied some moment, then this particular point, at this particular point, the beam can rotate theta is equal to infinity. If theta is equal to infinity, then what is the value of stiffness? M is equal to K into theta. If theta is infinity, what is the value of K? It should be 0. Getting a point? So the stiffness when the far end is free, it should be equal to 0, 0, 0, 0. Okay, mere hero, yaad ho gaya? Please remember these three conditions, very, very important. Okay. Now there is one more term which is nothing as relative stiffness. Now this relative stiffness is useful in which, or in that particular structure where we are using the same material. If you have same material, then in that particular case, you can use the relative stiffness in place of rotational stiffness term. But guys, the purpose of the relative stiffness and the rotational stiffness will remain same. Our purpose is to distribute the moment at a particular junction. And that's why guys, you can use any one of them. But in most of the cases, you have to use always rotational stiffness terminology guys, so that it will be more easy to remember, right? But if you have same material, you can use this term also, right? Now, the relative stiffness is nothing as basically K by 4E. Now, you know that guys, if far end is fixed, then the relative stiffness value is equal to how much? It should be 4EI by L divided by 4E. Now, if you cancel 4E to 4E, our value will become I by L. Please remember this point. If it is not written for which particular condition we have to find out the relative stiffness, kindly consider far end as a fix. This is general case. Okay. Okay. Next, when far end is hinge. So when far end is hinge, then what is the value of relative stiffness? It should be 3EI by L divided by 4E. So if you solve it, you will get 3I by 4L. Getting a point? Next one, when far end is free. If far end is free, then the relative stiffness is equal to how much? It should be equal to 0. It should be equal to 0. Clear? Okay. Now the next thing which is very important, carryover moment and carryover factor. Now guys, please remember this sign convention. What is carryover moment? We have already discussed, right? What is carryover moment? The moment which is developed at the far end, that is called as carryover moment. So let us suppose if your applied moment and this one is carryover moment. If your applied moment is clockwise, then carryover moment is also clockwise. If it is anti-clockwise, then the carryover moment is also anti-clockwise. Very simple to remember, right? If it is clockwise, then carryover is also clockwise. If it is anti-clockwise, then carryover is also anti-clockwise. Now tell me guys, when far end is fixed, you have applied certain moment that is equal to M. Let us consider this is near end, and at the near end, we have applied the moment M. Applied moment, and this is basically near end. Now let us consider this one is far end. So at the far end, if it is fixed, then what should be the value of moment and what should be the direction? The direction will remain same. If it is clockwise, then it is also clockwise. So this is clockwise. So MB is equal to how much? It is half of this. So it will be equal to M by 2. It will be equal to M by 2. Now how you can write carryover factor? How you can write carryover factor? carryover factor. Carryover factor. So carryover factor is the ratio of carryover moment upon applied moment. Carryover moment divided by applied moment. Divided by applied moment. So the ratio of these two value will give us the carryover factor. So for previous case, what is the value of carryover factor? What is the value of carryover factor? Carryover moment is how much? This is carryover moment, right? Let me write it down. This is carryover moment. And this carryover moment will develop at the far end. Right? So the value is equal to how much? M by 2. Applied moment is M. So this value will become 1 by 2. Very simple. So carryover factor is 1 by 2. That's it. Very simple, right? Okay, guys. Now anyone who can tell me, guys, what is the carryover moment when the far end is free? What is the carryover moment and carryover factor when far end is free? Quickly write down in the chat box carryover moment and carryover factor when the far end is free. Carryover moment is equal to how much and carryover factor is equal to how much? Write down, write down, write down. What is the value of carryover moment, carryover factor? No carryover moment, right? It should be equal to 0. It should be equal to 0. Please remember this. Very nice. It should be 0. Next condition, when far end is hinge or roller. Then again, tell me, guys, what should be your answer? This is A, this is B. Now let us suppose if I have applied the moment M, right? So what should be the value of carryover moment and carryover factor in this case? This is theta A, this is theta B. So tell me, guys, what is the carryover moment? Again, it is equal to 0 and carryover factor is also 0. So please remember, this is means only single cases there in which we will get the carryover moment and carryover factor. That is basically when the far end is fixed, right? And it should be half. But in this case, the value of theta A is equal to how much? Theta A is ML by 3EI. And this angle, please remember this value, it will be ML by 6EI. Please remember this. This is the half of the previous one. Or you can say that theta B is nothing as theta A by 2. Please remember the value, right? Theta B is equal to how much? It should be equal to theta A by 2. That is our theta B value. Clear? Understood? Any doubt? Any doubt? Any doubt? Any doubt? Please write down. Crystal clear? Very nice. Okay. Now let's understand the next thing, which is basically our different sway condition. Now what do you mean by sway? Sway means the deformation of a structure, and that deformation is basically the elastic deformation. Our structure may get a lateral deformation, right? But that deformation is elastic in nature, right? Up to elastic, we will consider the sway condition, or either our support may settle down, right? So these are the two possibilities due to which sway will occur in this structure. Now, what are the various conditions and how we can predict what is our direction of sway? Let me tell you that particular concept, okay? But I will use one sentence in Hindi, right? And I will convert it in also in English also, guys, so that everyone can understand this point. But first I will explain this particular means that sentence in Hindi only, okay? But basically it is a dialogue, right? So I will tell you about that, okay? So do you know that, guys, it is a general rule. ये दुनिया का उसूल है. क्या उसूल है दुनिया का? ताकतवर कमजोर को झुकाएगा और स्वयं वहीं आएगा. क्या आएगा भाई? वापस बोलता हूं, ध्यान सुनना. ताकतवर कमजोर को झुकाएगा और स्वयं वहीं आएगा, right? So you know that, guys, always a stronger one is trying to dominate over a weaker section, or you can say that weaker people, right? So this is a general rule, and the same rule is applicable in case of structure also. तो ताकतवर कमजोर को झुकाएगा और स्वे वहीं आएगा. आर यू गेटिंग अ पॉइंट और नॉट? प्लीज राइट डाउन यस और नो. So if you are able to understand this rule, then you are able to understand the concept over here very easily. Let's understand, guys. So first one is basically the different support condition. Let us suppose, guys, if you have a portal frame like this, in which this end is fixed and this end is basically hinge. Okay. And let us suppose, guys, the value of EI is constant. EI is constant and this is the length of member L. Now tell me what is the stiffness of this member. Can I say that this end is fixed? So 4 EI by L. Let us write K1. What is the stiffness of this member? It should be equal to 3 EI by L. So if you have more stiffness, then it is more stronger. If it is lesser stiffness, then it is weaker, right? So tell me, guys, which is stronger? 4 EI by L. So this column will try to dominate over the weaker column. So this member is trying to dominate over this one. That's why the direction of sway is this. ये कॉलम ताकतवर है, ये कॉलम हल्का है, तो ताकतवर कमजोर को झुकाएगा और sway इधर आएगा. Getting a point or not? So this is the direction of sway. कोई नहीं माधव, आप एक दिन का ब्रेक लो, अगले दिन से शुरू हो जाओ. एक दिन छोड़ दो, कुछ नहीं है गेट, भूल जाओ एक दिन के लिए, राइट? यू कैन फॉरगेट द गेट एग्जामिनेशन फॉर वन डे, देन आफ्टर वन डे you have to start it again. That is the only solution which you can do. Sumant, let me explain one point over here. First of all, you need to understand how we can predict the direction of sway, right? But we have certain special cases, you can say that. In this case, we don't have any kind of load. Getting a point? But still, I want to understand what should be the direction of sway which can be possible over here. So by this particular condition which we are discussing, we can use it. But in your question or in your examination, you may not get such type of question like you have a combination of conditions, like loading is also given, different you can say that unsymmetrical outline is given, stiffness are different. If you have such type of condition, then you need to use the complete analysis to find out the direction of sway. Otherwise, guys, it is not possible. But in your gate examination, you may have 1 mark problem, and then in that 1 mark problem, they can ask whether this particular structure will feel sway or not, or in this particular structure, what should be the direction of sway. So how we can predict it, that we are discussing over here, right? For 1 mark problem right now. Getting a point? But if you have a numerical condition, if you want to solve it completely, then you have to follow the moment distribution method complete process, which is a very lengthy problem, and such type of question cannot be asked in the gate examination. Getting a point? Okay. Now, it is easy. Easy. This one is easy. Different support condition, right? Next one. Next one. Unsymmetrical outline. Unsymmetrical outline. Unsymmetrical outline. What it means exactly? The support condition is same. The support condition are same. EI is same, but the length of member is different, or length of column is different. Let us consider this one is L1, this one is L2. But the EI value is constant. But the EI value is constant. Now tell me, guys, if I write the stiffness of this particular column, which is K1, so 4EI divided by L1, and the stiffness for this column is K2, which is 4EI by L2, right? Now tell me, guys, in this particular case, what will happen? Length is smaller. In this case, length is larger. So if length is smaller, then this particular value of stiffness is higher and this stiffness is lower. So can I say that, guys, again, the value of K1 is greater than K2. So ताकतवर कमजोर को झुकाएगा और sway इधर आएगा. Or you can say that this is stronger, this is weaker, so stronger will try to dominate over the weaker one, and that is the reason due to which we will have the sway in this direction. Okay, I will show you that also. I will show you that also. Okay, happy? It is easy or difficult? Tell me guys, it is easy or difficult? Easy or difficult? But guys, to be true, if I mix condition 1 and condition 2 together and try to find out the sway direction, it is not possible, because in such condition, what you have to do, you have to do the complete analysis. That is the only option which we can, by which we are able to get the direction of sway. Otherwise, if you have a single mark question, which you can expect in the GATE examination, you can use such type of concept to predict the direction of sway easily, right? Let's understand the third condition. Unsymmetrical section. What is unsymmetrical section? The value of EI is different, but the length of member, support condition is same. Let us suppose this is fixed, length is L, this is also L, but the value of EI is EI over here, and the value of EI is 2EI over here. That means unsymmetrical section. So if I write the stiffness of this member, which is K2, so I will write here guys 4 into 2EI by L, that means 8EI by L, and this one is K1 is equal to 4EI by L. Now tell me guys, in this case, can I say that the value of K2 is greater than K1? So this is stronger, this is weaker, ताकतवर कमजोर को झुकाएगा और sway इधर आएगा, right? So the direction of sway is this. This is the direction of sway. This is the direction of sway. Getting a point or not? Very nice. Very nice. The next one, which is very, very easy. Let us suppose guys, if you have a horizontal force, so due to that horizontal force, in the direction of force itself, we may have the direction of sway. So let's draw the figure also guys of deflected shape of the structure. So this is A, this is B, this is C, and this is D. Okay. Now let us consider, due to this particular load, which is basically F, we have the sway. But you guys, it is understood the direction of sway is like this only, right? Please remember this point, which is very, very easy. If you have certain force which is applied on the portal frame, so in the direction of horizontal force, the sway will occur. Very simple. Now the deflected shape of structure should be like this. Happy you can see this? Like this. Clear? This is the deflected shape of the structure due to horizontal force. Okay. Next one, the settlement of support. Let us suppose guys, if we have one support fixed, second support is also fixed. Let us consider this support is settled down by some value of delta. So that means this support will lower, right? It will be lower down by some amount of delta. Happy, we will draw further diagram also. Kindly see this. This is also delta. Now in this case, what will happen? This column will shift in the downward direction. Now this should be our deflected shape of the structure. Like this. This is your deflected shape of the structure, right? So in this case, you can see here, guys, what is the direction of sway basically. If your right support is trying to settle down, so this is our direction of sway. Yes or no? This is our direction of sway. Getting a point? Okay. The next one is basically unsymmetrical loading, which is very simple. Unsymmetrical loading means the loading is not symmetric throughout the structure. The loading is not symmetric throughout the structure. So let us suppose this is fixed, this end is also fixed. And let us consider we have a load at this particular location, which is not present exactly at the midspan, but it is present at a distance of A from the left part and it is at a distance of B from the right part. But in this case, A is greater than B. Very simple. Now guys, how you can observe which direction is our sway direction? So just cut the structure at the center in such condition. I will write it down, or I will write the statement. Cut the structure at midspan and judge the direction of collapse. Direction of collapse. Now kindly observe in which direction the structure is trying to collapse. So you can see, guys, this particular part will try to settle down in this direction, or you can, sorry. Right. This is the portion in which loading is there. So this particular part will try to move in this particular direction. So in this way, our structure will try to sway. Getting a point or not? That means our direction of sway is this. So guys, in your examination, you may have 1 mark question with respect to this concept. They can ask the direction of sway easily, but they have to provide the specific condition to judge the direction of sway. Otherwise, if you have a mixed condition or mixed concept, that is not possible to find out the direction actually. In that particular case, you have to apply the MDM completely, right? And such type of problem you can not expect in the GATE examination. Okay, LK, I will use the other color. So yes, now we have a different combination of color. Wait a second. Okay, I will use the yellow one. There is no white color right now in this particular portion or in this. I don't have white color. I can use the yellow one only, right? Okay. Let me remove this so that you are able to understand this statement. Let me remove this one. I will write it again. Use black, sir. बच्चा black पे black कैसे दिखेगा? How it is possible? Cut the structure at midspan and judge the direction of collapse. Clear? Arun and Prashant, we will use these colors on our white slide, or yes, white slide, right? If we have black slide or the dark color, then we have to use only the yellow one, because this is the only option which I have in this particular software. Okay, getting a point? Or either I have to check the setting, but it's better to use these color only, right? It's better. Clear? This one is yellow and this one is green. I think green is also not visible to you properly. Then we have, I think, blue, which is also not visible. Then we have red, which is also not visible. Some of the students are complaining for this, right? Then last option is black, which is also not visible. So only option which I can use is yellow. ठीक है? Now tell me which is better. Yellow is better? Okay, perfect. Now I think all of you are able to understand this one or not? Crystal clear, guys? What are the different sway condition? Red also fine. Okay, no problem. Now guys, what is distribution factor? What is distribution, how we can calculate the distribution factor? What is distribution theorem? I will explain. Then I will tell you some of the value of fixed end moment which you have to remember for your examination purpose, right? Then we'll solve some problem which is related to this chapter. So guys, what is our distribution factor? Distribution factor. So to understand this, it is very simple. Let's take some example over here. Then I will write down the formula to understand this. Okay. So let us suppose, guys, there are 4 friends who has started a business, right? And let us consider they have invested some amount. Let us suppose there are 4 friends. Let me write it down. Friend A, friend B, friend C, and friend D. Let us suppose A is investing 1 lakh rupees, B is investing 2 lakh, C investing 3 lakh, and D is investing 4 lakh in a business. They have combined their amount and they have started a business. So let us suppose the total amount is equal to 10 lakh, right? Now tell me, guys, let us suppose in this particular case, we have some profit. Let us suppose the company got some profit from a project and that particular profit is 5 lakh rupees. Now tell me, guys, how I can distribute this 5 lakh to A, B, and C. That is my question. Very simple. Tell me how I can distribute this particular profit to A, B, C, and D. Very simple question and the logical one. In the proportion of their investment. In the proportion of their investment. Very nice. Yes. In the same proportion, right? You can say that, guys, the proportion of investment we have to calculate how much proportion of their investment to the total capital, and according to that I will share this particular profit. So it is very simple. Tell me, guys, how much amount of profit A will get and how much amount of profit B will get, how much amount of profit C and D will get. Please write down in the chat box. If you are able to understand this, then it means you are able to understand the distribution factor. Very easy. 0.5, 1, 0.5 and 2. Guys, very simple. If I want to calculate how much amount of profit A will get, so the amount of investment by A is 1 lakh, total investment is 10 lakh, multiply by the profit which we are getting is 5. So guys, this is the value of profit which will be taken by the friend A, right? Okay, what about friend B? We have to write 2 divided by 10 multiply by how much? 5. So guys, this value will be 1 lakh. What about C? C will be 3 divided by 10 multiply by 5. So it should be 1.5 lakh, right? What about D? D is nothing as, that is basically 4 divided by 10 multiply by 5, and it should be equal to how much? 2 lakh. Now guys, it is easy to understand this or not? Tell me first. Then I will explain one simple concept so that you can understand the whole MDM. According to active partnership with equal proportion. Ashish, actually it should be depend upon the amount of investment. How much amount of invested or how much amount of they have invested in the company, because as per their risk, they should get the profit also, right? Now tell me, guys, what is this? What is this? This is basically a distribution factor. Listen carefully. Listen carefully. This is nothing as our distribution factor. This is our distribution factor for B. This is distribution factor for C. This is distribution factor for D. Now what is this? This is basically applied moment. This one is applied moment at a particular joint. How much amount of moment you have applied, right? This is applied moment. So applied moment multiplied by distribution factor will be the distributed moment. Distributed moment. Are you able to understand? Yes or no? It is simple or not? Then we will apply this concept to the structure. Please write down quickly, guys. Easy? Okay, very nice, very nice. So guys, in the real life, the amount of investment is basically the strength. But in case of structure, stiffness is the actual strength. So what is our distribution factor in case of structure part? Very, very easy. So distribution factor is equal to stiffness of a member divided by summation of stiffness. Getting a point? This is stiffness of a member divided by summation of stiffness at that particular joint. That is nothing as, that is basically our distribution factor. We'll solve some question to understand this, right? So K is nothing as stiffness of member and summation K is nothing as sum of stiffness of all the member meeting at that joint. Meeting at that joint. Very simple. So this is nothing as our distribution factor, guys. Crystal clear or not? Clear? Now, distributed moment. Distributed moment. Distributed moment is nothing as basically distribution factor multiply by applied moment, right? So distributed is nothing as it is the proportion of moment which should be resisted by a particular member according to their distribution factor. So this is our distributed moment. Getting a point? Clear? Yes or no? Please write down. Okay, very nice. So these 2 points is also clear to you. Now guys, the next thing which we need to discuss is very, very simple. Please remember these values for your examination purpose. It is important. Only 2 values are very important, or I will write three of them, right? Let us suppose, guys, if a P load is there, right, which is applied at a distance of A at a distance of B, right? Please remember these values. These are nothing as basically fixed end moments. Fixed end moments. I will write certain values which is very important for your examination because we have a lot of values to remember. But guys, I will tell you those values only which is very, very important. At least you have to remember this. Okay. So let us suppose this end is A, this end is B. Now, due to this particular load, what should be the value of fixed end moment at A and at B? So please remember, if you have a clockwise movement, please consider it is positive. If you have anti-clockwise movement, then it is negative. It doesn't mean clockwise means sagging or anti-clockwise means hogging. It doesn't mean that, right? It is just a sign of direction of movement. If it is clockwise, positive, anti-clockwise, negative. Very simple. Okay. So what is the value of MAB bar? We have to write fixed end moment at A for member AB. So this value is minus PA B square divided by L square. And this value is, please remember these values, right? MBA bar is equal to plus. Why it is plus? Because it is clockwise. So PA square B by L square. Okay. Now let us suppose, guys, if our load is present exactly at the midspan. If this particular point load is present exactly at the midspan. So this value is L by 2. This value is also L by 2. Let us suppose this is A, this is B. So what is the fixed end moment over here? It should be minus PL by 8. What about this one? Plus PL by 8. Please remember these values. Please remember these values. Next one is if we have UDL on the entire span. UDL on the entire span, W kilonewton per meter. So this value will be WL square by 12, and this value is also WL square by 12. It is anti-clockwise, negative, clockwise, positive. Getting a point? At least remember these values for your examination purpose. Very important. One more value, guys, which you have to remember. Let us suppose this end is also fixed, this is also fixed, and one of the support is getting settled down by delta. Like this. So the direction of settlement is downward. Let us consider, guys. And this value is delta. So this is A, this is B. So what is the value of moment? This is our MAB bar, which is equal to minus 6EI delta by L square. This value will also be anti-clockwise. It should not be clockwise. It is also anti-clockwise. Please remember this. So MBA bar is equal to how much? Again, minus 6EI delta by L square. Minus 6EI delta by L square. Getting a point? Let us suppose, guys, if both the ends are hinge. If both the ends are hinge. So in that particular case, what will happen? No moment will develop. Still we have some settlement of support, but no moment will develop over here. It should be 0, and this is also 0. Getting a point? Yes or no? Let me add one more concept. Please remember these values. These are the standard value which you have to remember. Let us suppose this is fixed, this is hinge. And our hinge support is settled down by some delta value. Then what should be the value of moment which should be developed over here? So please remember, guys, this value will be minus 3EI delta by L square, and this value is 0. Clear? So already direction considered at the left as anti-clockwise, then why again negative? Okay, listen. Sumant, as we know that if the clockwise direction is positive and anti-clockwise direction is negative. Yes? Okay. Now listen. Usually you have to just put the direction and write the value. You have to put the direction and write the value. But while solving the question, we are not writing the direction. If you want to show the direction, you need to use the sign. Getting a point? Let us suppose if I want to tell what is the moment at support A. So I will write it minus PAB square by L square. By using minus, I am able to understand the direction is anti-clockwise. So in the figure, I know that it maybe get conflict, but in the actual condition, you have to use these values only. That's why I'm writing it. Okay. So don't mix this particular thing and don't take it otherwise, right? Clear, Sumant? My phone is charging. That's why I have to see over here. Please tell me, Sumant. My phone is charging. That's why I'm seeing here, guys. Or let me remove it. Okay, now tell me. Okay, fine. Super. So please remember these values at least for your examination purpose, right? So that you can solve the problem. Okay. So let's solve some of the question, guys, which is based upon this, and then we'll move to the next part. Okay. Now, guys, this is one of the question which was asked in the GATE examination. What we have to do, we need to calculate the magnitude of rotation at junction R, or you can say that at joint R. Very, very simple question. What is the value of theta R that we have to calculate as per the question? How we can do it? First, we have to break the structure. Let's take this particular structure separately for our analysis part. Then I will tell you some short trick also, guys, to solve the question. Okay, this is basically a free end, and at the free end we have a force which is basically P, and this length is L by 2 and this length is L. Now if I break this particular member at this particular point, then tell me, guys, what is the value of moment? This is P into L by 2 So can I say that, guys, this moment will be PL by 2? And similar moment we will have over here also, PL by 2. Yes or no? Getting a point? So the value of M is equal to how much? PL by 2. So do you remember this concept, guys? If you're applying some moment M and this is A, this is B. So what is your deflected shape? It should be like this. So what is the value of theta? This is our theta A. What is this? This is our theta B. So what is the value of theta A? Do you remember? Theta A is equal to ML by 3EI. And theta B is equal to how much? ML by 6EI. Getting a point? So in this case also we have to find out theta R. Right? This is our applied moment. So what is the value of theta R? That we have to find. So tell me, guys, what is the value of theta R? Any one of you who can give the correct answer? Theta R should be equal to how much? ML by 6EI. Now what is the value of M? M is equal to PL by 2. So it should be PL square by 12EI. Right? So tell me, guys, which is the correct answer? Let me hide myself. Let me hide myself. Okay. Now tell me the answer, guys. Which is the correct one? Dinesh, PL square by 12EI. PL square by 12EI. PL square by 12EI. Very nice, guys. Very nice. PL square by 12EI. Very nice. Superb. 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 Next question. Now, guys, this is a question. If you want to solve it by using a simple concept like distribution factor, we'll solve it also in the form, in that form also. But guys, I will tell you the trick over here. Right? What is that trick? Very simple. Tell me, guys, right now what we have to do, we have to find out the distribution factor for member CB, CD and CG, right? So tell me, guys, for this particular member, for this particular member, for this particular member, can I say that far end is fixed? If far end is fixed, then the stiffness is very simple to write. K is equal to 4EI by L. That means 4EI is constant for all the members, whether it's CB, CD and CG. Okay. So can I say that, guys, our stiffness value should be inversely proportional to length. Okay. Now you know that, guys, how to write down the distribution factor. Distribution factor is K upon summation K. And summation K is constant for all the distribution factor values. So we can write here, guys, distribution factor is proportional to K. If it is proportional to K, it is proportional to 1 by L. That means it is very simple. If the length of member is higher, then the distribution factor will be smaller. If the length is lesser, distribution factor will be higher. By using this concept, we'll take the answer. Right? So tell me, guys, which particular member is smaller? CD. So the distribution factor for CD should be higher. Now let's read the values. CD is in middle, right? CD is in middle. So the middle value should be higher. Let's see, guys, in which case we have higher value, B and D option. So we can cancel A and C easily. Now the member which have more length, which is basically CB. So this value should be lesser. So 0.24 is lesser. So that's why B is the correct answer. Now tell me, guys, without solving the problem, still we are able to solve it. Without solving the problem, still we are able to solve it. That's why the correct answer is B. The correct answer is B, not D. Now tell me, guys, it is easy or difficult? And please hit the like button, guys. Don't forget to hit the like button, right? Like button दबा दो यार एक बार. Yes, you can say that. CB is double of CD. So that's why we can say that B is the correct answer. Right. But guys, let's understand by our concept also, because it is also important. Right. So by using the formula, let me solve this problem. Now you know that, guys, what is our distribution factor? So first I will write the stiffness for CD member. It should be 4EI by L. L is equal to how much for CD? It is 4 meter. So this stiffness is EI. Then for CB, 4EI by 8. So it should be EI by 2. Then 4EI by 7. So K CG. 4EI by 7. That means it is 4EI by 7. Okay. Now guys, the distribution factor for CD member is equal to KCD upon summation K. Now please calculate the summation K value. Add all the values first. Add all the values. 1 plus 0.5 plus. So this value is coming around 29 by 14 EI. Okay. So EI divided by 29, EI divided by 14. If you solve it, how much you are getting? So this value is coming around 0.4827 for CD. Then distribution factor for CB. So KCB is how much? EI by 2 divided by summation K, which is 29 EI by 14. So we are getting a value of 7 by 29. That means 0.2413. Then distribution factor for CG. CG is equal to how much? 4 EI by 7 divided by 29 EI by 14. So this is value is coming around 0.2758. That means 0.28 you can write here. So in this way you can solve it also. But guys, now you are able to understand how to use the distribution factor formula and how we can apply the short trick also. Okay, very nice. Now let's solve another question, guys. Let's solve another question. Now this is the question which was asked in the GATE examination, guys. Again, we need to find out the rotation at joint Q. At this particular joint, we need to find out the rotation. So how we can calculate the rotation? Please remember the formula. It is nothing as it is the M is equal to summation K into theta, right? So just you have to calculate the summation of stiffness at that particular junction where we have to find out the rotation, right? And the value of moment and the value of stiffness, summation of stiffness. So let's do it. First, I will break the structure. First, I will break the structure. It's 1650 kilonewton per meter. And this one is 2000 kilonewton, and the distance which is written over here is 2 meter, and this distance is basically 4 meter. This one is also 4 meter, and EI is constant for all the members, right? Now guys, first of all, we need to estimate what is the value of moment at this particular location, right? The same amount of moment we have to apply at the junction, right? So let's calculate the moment at this particular location. Let's write it down, mxx. So it will be equal to 1650 multiplied by 2 multiplied by 1 minus 2000 into 2. Please calculate this, how much you are getting. So guys, this value is coming around minus 700 kilonewton meter. That means the direction is what? Anti-clockwise or clockwise? Tell me guys. The direction is anti-clockwise. The net moment which we are getting is anti-clockwise. Yes or no? Anti-clockwise. Okay, no problem. Now guys, let us suppose this is the direction of movement. So the moment which we have to apply over here is like this. The value is 700 kilonewton meter. Now guys, what is the value of theta B? This is our joint Q, sorry. So we have to write M is equal to summation K into theta. So theta is equal to M upon summation K. What is the value of moment which we have? 700. Multiply by 10 raised to power 6. So that is converted into Newton mm. Now divided by summation stiffness. What is the sum of stiffness at this junction? 4 EI by L and 4 EI by L. So sum of stiffness is 4 EI by L. L means 4. 4 EI by L. L means 4. Getting a point? Okay. The value of EI is already given. E is this. E is this. And I is this. So let's calculate the value of summation K first. So it should be 2EI. Or what I will do, guys, I will write it down in this way so that we can correct the dimension also. Clear? Now let's correct it. 8 into E. E value is 2.5 into 10 raised to power 4. Which is in Newton per mm square. Then we have I. I is equal to how much? 8 into 10 raised to power 8. Which is in mm raised to power 4. Now divided by 8 meter. Meter means we need to convert it in terms of mm. Like this. So kindly cancel the dimension. It should be square. Now you can cancel this one also. Then what is the value of summation K which we are getting? Please write down. Okay, sorry. 8 EI by 4. 8 EI by 4. Sorry guys, it should be 8 EI by 4, not 8 EI by 8. It should be 8 EI by 4. Right. Please calculate this. How much you are getting? Please write down in the answer. Four into 10 raised to power 10. Are you getting this? 4 into 10 raised to power 10. Are you getting this? Please check it out. 4 into 10 raised to power 10. Summation K. Okay. So just put this value to get the result. Right? And the unit is same. Again Newton mm. So please calculate what is the value of theta which you are getting. So guys, the theta value which we are getting in terms of radian, and that is equal to 0.0175 radian. This is not in degree. If you want to convert it, I need to multiply it by 180 divided by pi. So as per our question, we need to find out the value in terms of degree, right? So please multiply this value. Please multiply this value theta 0.0175 multiply by 180 divided by pi. You will get the answer in terms of degree. So guys, it is coming around 1 degree approximately. So theta is 1 degree. That means that joint is rotated by 1 degree, and the 1 degree rotation you are not able to see by the naked eye. And that's why in our actual structure, we are not able to see the actual rotation which is occurring, because it is very difficult. Like how you can see the 1 degree rotation at the junction. Are you able to understand? But still it is occurring in the structure due to the given loading. Are you able to understand? Okay. Now guys, the next chapter is basically our slope deflection method. These are the fundamental which you have to remember again, okay, for MDM method. Okay, now let's move to the next chapter guys, which is basically our slope deflection method. First we'll discuss the slope deflection method. So up to this, any doubt if you have, please write down guys in the chat box. Any doubt, any doubt, any doubt? Crystal clear to all of you? Okay. So guys, at after this particular chapter, let's take a small break of 10 to 15 minutes, right? After this particular chapter, then we'll continue our session. 10 to 15-minute break, right? Okay, after this particular chapter only. Okay. So guys, the next chapter is basically your slope deflection method. Slope deflection method. Again, guys, this particular chapter is not too much important as per the GATE examination point of view. But still, guys, there are certain things which you have to just remember, right? If you are able to remember it, you are able to solve the problem, right? So slope deflection method is another type of displacement method. Another type of displacement method. It is another type of displacement method. Okay. Another type of displacement method. Now, guys, slope deflection equation. What is slope deflection equation? Do you remember? Slope deflection equation. Now let us suppose, guys, if I have a continuous beam and I want to write the slope deflection equation for any beam, let us suppose this is our continuous beam and this is point A, this is point B. And I want to write down the slope deflection equation for AB and BA. Then what it is exactly? So MAB can be written as MAB bar, which is basically fixed and moment due to the external loading, plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. This is the formula. Second, MBA is equal to MBA bar plus 2EI by L into 2 theta B plus theta A minus 3 delta by L. Now what is theta A, theta B? It is nothing as it is the rotation at A and at B. What is the rotation value at A and B? And delta is nothing as basically it is the displacement or the settlement of point A or point B, or support A or support B. Now please remember some of the sign convention over here, guys. If fixed and moment, if it is clockwise, then it is positive. If it is anti-clockwise, then it is negative. Theta, that means rotation. If rotation is clockwise, again it is positive. If it is anti-clockwise, then it is negative. Now, if settlement, please remember this, right? If settlement of support is clockwise, what do you mean by clockwise? If clockwise, let me show you that. Let us suppose, guys, in this way, the settlement is occurring. In this way, settlement is occurring. That means settlement direction is clockwise. Then please consider delta value is positive. If it is anti-clockwise, then the settlement will be like this. Then our delta value should be negative. Please remember these signs, very important. Fixed and moment, clockwise positive, anti-clockwise negative. Theta, clockwise positive, anti-clockwise negative. Settlement, clockwise positive delta, anti-clockwise delta is negative. Very simple. Next, how we can write down the joint equilibrium equation? How we can write down the shear equation? That is another question. After writing slope deflection equation, guys, let us suppose this is our structure which is given to us. Let us suppose this is O, this is A, this is B, this is C. So I want to write down the joint equilibrium equation at joint O. So guys, what you have to do, you have to break this particular joint, break this particular joint, break this to particular joint, and apply the moment on the member in a clockwise direction. Clockwise, 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 clockwise. So the respective joint will get the moment in an anti-clockwise direction. Simple, right? So guys, this value is MAO. This one is MOA, MOB, MOC. This one is MBO. This one is MCO. Now guys, please remember this point. The summation of moment at each and every joint will be equal to how much? 0. And that is nothing as, that is our joint equilibrium equation. So joint equilibrium equation is equal to how much? It is basically summation moment at O is equal to 0. So we'll write minus MOC minus MOB minus MOA is equal to how much? It should be 0. So MOC plus MOB plus MOA is equal to how much? It is equal to 0. And this is our joint equilibrium equation. This joint should remain in equilibrium if such condition prevails. Crystal clear? Like this. So in this way, you can write the joint equilibrium equation further in your different joints. Now guys, the next one is basically the shear equation, which is very, very important. Shear equation. How we can write it down? Let's understand in detail. Let us suppose this is our structure. And we have a horizontal load like this. And due to this horizontal load, our structure will have certain deflection. Let us consider that is basically delta. Now please remember this. If you want to find out the value of delta, you need to write down the shear equation to find delta. If you want to find out theta, to find theta, that means rotation, we need to write joint equilibrium equation. Very simple. So if you have 10 number of delta, then 10 shear equation you have to write. If you have only one delta which is unknown in the structure, only one shear equation is required. If you have 5 theta which is unknown, then you have to write 5 joint equilibrium equation. In this way, you can say that guys, the number of equation which is required. So the number of theta is equal to the number of joint equilibrium equation required. The number of delta is equal to the number of shear equation required. Simple. Now guys, let us consider this is A, this is B, this is C, and this is D. And this is basically our delta. As we have discussed, we need to break the structure first. Kindly break it at this particular location. Why we are breaking it? Why we are breaking it? Let me explain. Guys, tell me, due to this horizontal force, this particular upper part may get shear off, right? So, okay, sir. So, definitely we will have certain horizontal reaction at the support. Let us consider that is HA and this is HD. So, in this direction, you have to write HA, HD, HA, HD. Getting a point, right? So this is basically HA, HA, HC, sorry, HD, HD. Now do you remember guys, we have discussed the moment should be applied on the member in a clock. Okay. Now in this particular case, you can see here guys, the moment should be applied like this. In this case, the moment should be applied like this. Why we are applying it in this way? Because the direction of settlement is basically what? Clockwise. The moment should be anti-clockwise in this case, right? For this particular column and for this particular column. It is very easy. Now what I will do guys, first I will write down the summation moment at A for this particular portion. So summation moment, let us suppose L is the length. Summation moment at A is equal to 0. So this moment is MBA. This one is MA. What you can do guys, let's use the same principle which we have discussed. we'll apply the moment in a clockwise direction. Simple. Okay. Kindly use the same principle so that you will not get confusion. Same principle we will use. Let's apply the clockwise moment, because after solving the question you will get always means you will get the sign of the moment according to their actual direction, right? But in the initial condition we'll consider it as a clockwise in nature. Okay. So this is AB and this one is BA, this one is CD and this one is DC. So summation moment at A is equal to 0. So we'll write here guys HA into L plus MAB plus MBA is equal to 0. So our HA value should be equal to how much? Minus of MAB plus MBA divided by L, and this is one of the value which we are getting. In the same way, we have to solve this particular column also. So guys, after solving this, if you write summation moment at D is equal to 0, what you will get exactly? HD is equal to minus of MCD plus MDC divided by L, right? Getting a point or not? Now tell me guys, after writing these two value, what you have to see? This upper part should be in equilibrium, right? And what are the forces which is trying to oppose this particular applied force? HA and HD. Getting a point? So can I write here guys summation Fx is equal to 0? If summation Fx is equal to 0 for this particular part, which is the upper part, we'll write here P minus HA minus HD is equal to 0. So it is very simple. HA plus HD is equal to P. And the value of HA and HD is known to us. Getting a point? No, Ashish, HA plus HD is equal to P, because these are the two reaction which is trying to oppose P value. Clear? Now guys, HA and HD this, so we'll write here minus MAB plus MBA divided by L minus MCD plus MDC divided by L is equal to P. So we'll write here our shear equation will be MAB plus MBA divided by L plus MCD plus MDC divided by L plus P, and it should be equal to 0. So this is known as shear equation. In this way you can write it down. But guys, again, your examination they will not ask such type of you can say that only in 1 mark question they can ask what is shear equation. Otherwise, if they give a problem which is related to the slope deflection method, and to solve it completely, you can solve that particular question by using MDM also, because it will be more easy to solve the problem by using MDM instead of using slope deflection method sometime, right? So guys, this is basically our shear equation. So these are the fundamental which you have to remember for your GATE examination in case of slope deflection method. So all of you are able to understand whatever we have discussed till now. Then we'll take a 15-minute break, right? And we'll come back at 8 p.m. Okay. So up to this, any doubt? Then we'll start it again, guys, and we'll discuss the arches, cables, and ILD, and then matrix method, which is the last chapter. Crystal clear? So let's take a break up to 8 p.m. So class will start (8 p.m.), right? I will come back at 8 p.m. guys. Okay. Let's take a break of 15 minutes. Okay. Till that, you can take your dinner also, guys, if you want. Okay. So let's come meet again at 8 p.m. guys. Let's take a break. Hello, 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 hello. Now audio is there. Swapnil, hello, how are you? Excuse me. Okay, perfect. So let's continue our session, guys. As we have discussed about the moment distribution method, slope deflection method. Excuse me. Strange method. Now we have to start arches cables, ILD part, and the flexibility and stiffness matrix. So these are the topics which we have to discuss still. Okay. Okay, guys. So what is basically the arch? You know that, guys, arch is nothing as it is a curved member. Why we are using it? Because in case of large span structure, if you use the arches, that is more economical as compared to beam. Because if you provide the longer length of beam, then in that case, much amount of deflection may occur. As well as the amount of movement which is developed in that particular case will be higher, because you know that, guys, the bending moment is proportional to length of the member. Like if you have a L length, so in that particular case, let us suppose our UDL is there. So the moment is WL square by 8. So if your length is higher, then definitely the moment will be higher. So if moment is higher, the more material is required. But in case of arch, what will happen? We may have a lesser moment for the same span, for the same loading condition, and that is the reason due to which we are preferring the arches as compared to the beam. That is the main thing. Now, if you talk about the classification of arch, so basically there are two type of arches on the basis of indeterminacy part. One is basically determinate arch. You know that what is determinate. If you have a three-hinge arch, then it is a determinate arch. Three-hinge arch is a determinate arch. Three-hinged arch is a determinate arch. As you can see here, guys, one of the hinge is placed over here, second hinge, third hinge. So it is three-hinge arch. Next one is basically indeterminate arch. Indeterminate means whose static indeterminacy is greater than 0. So there are two examples. One is two-hinge. One is basically two-hinge arch, two-hinged arch, and the second one is fixed arch. So these are the two arches which comes under the indeterminate arch condition. But guys, as per your GATE syllabus, let me tell you one thing. As per your GATE syllabus, you have to just understand two-hinge arch and our three-hinge arch. But if we see the past data, or if we see the past PYQ, what we have found, basically there are very less number of questions from this particular chapter. Why, I don't know, but it is a very nice chapter, guys, as well as a very conceptual part which is basically arch portion. But still they are not asking too many questions from the arches. That means you have a very lesser probability from this particular chapter, or you can expect very less number of questions in the GATE examination, right? Or it may be possible there is no question from the arch portion also, right? But if you have a question from this chapter, then what type of question you can expect? They can ask the horizontal thrust reaction. What should be the horizontal thrust, right? What should be the horizontal support reaction you may have on different loading condition? That is a one major part which is very important. Second, how to find out the normal thrust and the radial shear. So these are the 2 points which is very important as per your GATE point of view. So please try to understand these type of things from this particular chapter mainly. Okay. So guys, these are the two arches which is based upon the indeterminacy. Now if you talk about on the basis of shape, then we have parabolic arch, circular arch, spiral arch. Spiral arch is not in our syllabus. Semicircular part or arc of a circle can be asked in the GATE examination. Parabolic, semicircular, and arc of a circle. Okay. Okay. Now guys, let's understand certain cases, okay, over here, and in detail we will try to solve it also. Okay. So let us understand how to solve the three-hinge parabolic arch. So let us suppose, guys, this is our arch which is given to us, and a point load is placed at the crown itself, and we need to find out the horizontal support reaction. What means actually, what is the value of HA and HB? That is our question, and this is a parabolic arch. So you can see, guys, H is our rise, L is our span length. L is our span. Now what we have to do, guys, we need to apply the static equilibrium equation in this particular case. Use the static equilibrium equation. Static equilibrium equation. So what we will write, guys, first I will write summation moment at B is equal to 0. So that we are able to find out the value of VA easily. VA into L minus W into L by 2, and it should be equal to 0. So VA is equal to how much? V is equal to how much? W by 2. So if I write summation Fy is equal to 0, so VA plus VB is equal to how much? VA plus VB is equal to how much? VA plus VB is equal to W. So VB is equal to how much? Again it is W by 2. So these are the two values which we are getting right now. Now guys, what type of question you can expect? They can ask the resultant reaction at the support. They can ask what should be the reaction at the support A in the horizontal direction, at support B in the horizontal direction. That means HA and HB value. So guys, what we have to write? Moment at C is equal to 0. At this particular crown hinge, we can write moment at C is equal to 0 easily from either of the side. So you have to write down VA into L by 2 minus HA into H, and it should be equal to 0. So what is the value of HA, guys? HA should be equal to VA into L by 2H. Now what is the value of VA? W by 2. So our answer will be WL by 4H. So in this way we can solve the problem. So please remember this reaction. The horizontal thrust reaction is equal to how much? WL by 4H. WL by 4H. Clear? So guys, let us suppose if I want to find out the resultant reaction at support A. What is the value of RA? So can I write here RA is equal to what? RA is equal to under root of VA square plus HA square. Correct? Let's put the value to get the answer. So under root of W by 2 whole square plus WL by 4H whole square. By using this formula, you are able to get the value of RA easily. Clear? By using this formula, you are able to get the value of RA. Now let us suppose, guys, if I want to ask you, what is the value of theta? Let me hide myself so that you can see this particular calculation which we have done. So you can see, guys, this is our value of VA, this is the value of HA. VA square plus HA square is the answer. Now guys, what is the value of theta? What is the value of this theta? How much inclination is there with respect to horizontal support reaction? So we need to write tan theta is equal to VA by HA. So VA is equal to how much? VA is equal to W by 2, HA is equal to WL by 4H. So this value will be 2H by L, and that is our tan theta value. So theta is equal to how much? Theta is equal to tan inverse 2H by L, and this is nothing as this is our angle of inclination of resultant reaction with respect to horizontal. In this way, we can calculate this. Clear? Very easy, right? Okay. Now let's understand, guys, how we can find out. Now let's understand how we can find out the normal thrust and the radial shear at any location or at any distance x, right? What is the formula for that? Let's understand it. So let us consider a distance x, and this particular distance is y. Rise is y. Now if it is a parabolic arch, then we have to use an equation of parabola. Let's use a different slide so that we can use multiple color easily. So guys, what is the equation of parabola? Equation of parabola. What is the equation of parabola? Y is equal to 4hx divided by L square bracket L minus x. This is the equation of parabola in which y is the rise at any distance x, h is the central rise, L is the span value. Getting a point? Now guys, let us consider This is our arch. Okay. This is our arch. And I need to find out the value of normal thrust and the radial shear at a distance of x. Let us consider this is central rise, which is h, span is L. And let's mark a distance of x over here. This is x and this one is y. This one is y. Let us suppose this is A, this is B. Let us consider this one is VA and this one is HA. This one is VB, this one is HB. VA, HA, VB, HB. Now guys, we know that this is basically a three-hinge arch and we have a load exactly at this particular location. So what you have to do, you have to break the structure at this particular location where you have to find out the normal thrust and the radial shear, right? So let's draw a free body diagram. This one is VA and this one is HA. This one is VA, this one is HA. And this is our rise, which is basically y, and this one is x. Now guys, you have to represent the normal thrust in this direction, right? And the radial shear should be like this. Radial shear should be like this. This is our radial shear. This is our normal thrust. Now what you have to do guys, you have to find out the two component of forces. One is horizontal and second is vertical. So you need to find out the value of Hx and the Vx value. And please remember, in case of parabolic arch, we have the angle with respect to horizontal always. Or you can say that it is basically a tangent with respect to the surface and you have to find out the angle with respect to horizontal for that particular tangent. That is nothing as our theta, right? So guys, how we can find out the theta value, I will tell you later on. But right now what you have to do guys, you have to use the static equilibrium equation. That means summation Fy is equal to 0, Va minus Vx is equal to 0. So Vx is equal to what? Va, and Va is equal to how much? W by 2. Then we have to write summation Fx is equal to 0. That means Ha minus Hx is equal to 0 and Hx is equal to Ha, and Ha is equal to how much? WL by 4H. That is our Hx. Now guys, please remember the formula to write down the normal thrust. So normal thrust is equal to how much? Normal thrust is equal to, now listen guys, this is Hx and this is Vx. You need to take the component of Hx and Vx in the direction of normal thrust, in the direction of radial shear. If these components are in the direction, or you can say that it is along to the normal thrust direction, that is positive. If it is opposite to the direction of normal thrust, that is negative. So guys, Hx cos theta is positive plus Vx sin theta is also positive. Now put the value to get the result. So WL by 4H cos theta plus W by 2 sin theta, and this is our normal thrust at that location. Getting a point? Now the question is, what is the value of theta? That we will discuss after this particular calculation, right? Now guys, radial shear. So radial shear is equal to this Vx will have theta with respect to radial shear. So we can write here Vx cos theta, but minus. Why we are writing minus? Because this Hx will be in opposite direction of radial shear. That's why guys, Hx minus Hx sin theta. So Vx is equal to how much? It is W by 2 cos theta minus WL by 4H sin theta. In this way, you can calculate the radial shear also. Now the question is, sir, what is the value of theta? It is very simple. You know the equation of parabola, just write it down. Y is equal to 4hx divided by L minus L minus X divided by L square, not L, it should be L square, right? Now guys, if you want to find out the value of rise at any distance of X, kindly put the value of X, you will get the rise. But if you want to find out the angle at any distance X, right? So we have to take the derivative of it, dy by dx, which should be equal to tan theta. And tan theta is equal to 4h divided by L square bracket L minus 2x. So kindly put the value of X. Now you are able to calculate what is the value of theta easily. Getting a point? Clear? Tell me guys, it is crystal clear to all of you or not? Any doubt? Any doubt? Any doubt? Any doubt? Very nice. Now let's move further, guys. Now, let me tell you some standard case and please remember these values, okay? Please remember this value, guys. If you have a UDL on the entire span and it is a 3-hinge parabolic arch, then what is the value of horizontal thrust? The value of horizontal thrust is WL square by 8H. Please remember it. WL square by 8H. Please remember the value, very, very important. WL square by 8H. But one more condition, guys, the bending moment in this particular case, if you have a UDL on the entire span, in case of 3-hinge parabolic arch, then the bending moment should be equal to 0 at every section. Yes or no? At every section, the bending moment value is equal to how much? It should be equal to 0. Right? Very important point, guys. You already know this, but I am just giving you a complete revision, right, for this, so that you can recall the concepts. It should be equal to 0. Yes? अरे बाबा, tell me यार. हाँ या ना बच्चा लोग. Yes, very nice. Okay, next one. Wait a minute. Okay, now the next condition is, let us suppose if you have 3-hinge parabolic arch, again, but half UDL is placed, or you can say that a UDL is placed on the half span only. UDL is placed on the half span. That means L by 2 length only. So in such condition, what is the horizontal thrust? It should be the half of previous value. That means H is equal to WL square by 16H. Similarly, guys, if we have a UVL, uniformly vary load, right? Uniformly vary load, like this, whose intensity is equal to how much? Whose intensity is W kilonewton per meter again. And we have support condition again, guys, which is similar to the hinge support. And this particular reaction will be again same. It is equal to WL square by 16H. WL square by 16H. Similarly over here, guys, also WL square by 16H. Please remember these values, all are important. Next one is semicircular condition. If you have a semicircular arch and a point load is placed on a 3-hinge semicircular arch, let us suppose this is W, then what should be the value of horizontal thrust? Any one of you? What is the value of HA? What is the value of HB? Any one of you? Do you remember? What is the value of HA? What is the value of HB? Any one of you guys who can tell me the answer? Do you remember this? VA is equal to how much? It is W by 2. This one is also W by 2. So what is the value of HA and HB in this case? what is the value of HA and HB in this case? Please write down. Guys, it is a semicircular arch. Semicircular means this is 2R and this is R. WL by 4H. Arey baba re baba. You forget the things. It is a semicircular arch, bachcha log. Semicircular arch. That means you have to consider MC is equal to 0. Movement at point C is equal to 0. So you will get the value of HA easily. W by 2. Arey bachcha log, it is W by 2. 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 Very easy, yeah? W by 2. The same value is valid, right? W by 2. Okay. If we have a UDL on the entire span in a case of 3-hinge semicircular arch, then what should be your answer? Tell me, guys. This is what? This is basically WR by, or WR, sorry. This is WR. And what is this? This is again WR. But what is the value of HA and HB? What is the value of HA and HB? Tell me, guys. What you have to do, let me write it down. Moment at C is equal to 0, right? Either from the left side or right side. We have to write VA into R minus HA into R minus W into R by 2, it's equal to 0. So VA is WR, so it will be WR square minus WR square by 2 is equal to HA into R. So HA is equal to how much? It should be WR by 2. WR by 2. So please remember these values also. WR by 2, this one is also WR by 2. Guys, we are discussing the standard case, and these standard cases are very important. Why? Because they can ask you directly in the exam what should be the horizontal thrust. So if you remember this, then you are able to take the question easily or answer easily, right? But let us suppose, guys, if you don't remember the value, then in that situation, you know the solution, you know the approach, how to do it. But in that particular situation, what you have to face, means you have to use a lot of time of your examination to solve that particular problem, right? Which will be a little bit, you can say that, guys, wastage of our time, right? If you have some, means if you utilize this particular time to solve another question, that will be much beneficial. That is the reason due to which you have to remember certain values, only certain values. Okay, that is my suggestion. Now, guys, if you talk about the two-hinge arch, so in case of two-hinge arch, semicircular arch and the parabolic arch, as you know that in semicircular arch, the value of moment of inertia is always constant. And the moment of inertia in case of parabolic arch, it will vary in the way of I naught sec theta. What is I naught? I naught is the minimum moment of inertia at the crown. And it will be maximum at the support. And sec theta is our variation basically. Okay. Please remember this. Now, let me hide myself first. Okay. Now you can see, guys, this is basically our two-hinge semicircular arch. If a point load is placed exactly at the midspan, then what should be the value of horizontal thrust? This is two-hinge, not a three-hinge. For two-hinge condition, the horizontal thrust value is equal to W by pi. Please remember this, guys. They have asked one of the question which is related to this concept. Okay, W by pi. But let us suppose, guys, if a two-hinge arch is there, let me write the formula first. I think you remember this formula. First, I will write that formula, then I will discuss the further things. Okay, wait a second, guys. I will write certain formula over here. Do you remember, guys, how to calculate the horizontal thrust? In case of two-hinge arch? Tell me yes or no. let's write it down. So M arch can be written as M beam minus H into Y. Do you remember this? M arch can be written as M beam minus H into Y. So guys, our total strain energy can be written as integration M arch square ds upon 2EI. Correct? Now you have to write down the value of M arch in the equation. How many of you are not able to, do not know this equation? Please write down the chat box. I will explain this. Otherwise, we'll continue. Okay, please write down, guys, if you don't know how this equation came actually. If you don't know, then I will write it down. Otherwise, I will continue. M beam minus Hy whole square ds upon 2EI. Now guys, as per our Castigliano's second theorem, you have to take the first partial derivative with respect to the total strain energy, of this total strain energy with respect to H, so that in the direction of horizontal thrust, the value of displacement is equal to how much? It is equal to 0. So guys, we'll write down del ut by del H should be equal to 0. If it is equal to 0, then the derivative will be twice of M beam minus Hy ds multiplied by minus y ds divided by 2EI, and it should be equal to 0. 2 to 2 cancel. Now guys, our equation will be minus M beam multiplied by y ds divided by EI plus integration H into y square ds upon EI, and it should be equal to 0. So our formula which we have to use to calculate the horizontal thrust in case of two hinge arches, integration M beam y ds divided by EI divided by integration y square ds upon EI. So this is the formula which you have to use to calculate the horizontal thrust. Clear? For horizontal thrust calculation, this is the formula which we are using. Clear? What is M beam? Beam moment, which means the bending moment due to the vertical loading only, right? Okay. Okay. Now guys, let's understand the values. So let me show you these values, which is standard values. Please remember these values. So W by pi in case of semicircular arch, two-hinge semicircular arch, and if load is present exactly at the crown. If load is present at a distance of x, or you can say that at an angle of alpha, in case of two-hinge semicircular arch, the formula will be W by pi sine square alpha. W by pi sine square alpha. Now guys, tell me, if load is present exactly at the crown, so the value of alpha is equal to how much? It should be 90 degree. If it is 90 degree, then the horizontal thrust will come W by pi automatically. W by pi automatically. Right? Remember this. Next one. If you have a two-hinge semicircular arch and a UDL is placed on the entire span, then the value of horizontal thrust is equal to how much? It is 4 by 3 WR by pi. 4 by 3 WR by pi. 4 by 3 WR by pi. Please remember this. Next, if you have two-hinge semicircular arch and a UVL is placed on the entire span and it is two-hinge semicircular arch, then the value is 2 by 3 WR by pi. That means it is the half of previous one. The previous one is 4 by 3 and this one is 2 by 3. Please remember this. Next, if you have two-hinge parabolic arch, for two-hinge parabolic arch, I will show you the values over here. We have the values. Wait a minute. Right. Okay. Now guys, for two-hinge parabolic arch, if a point load is placed, two-hinge parabolic arch, if point load is placed, force method तो पढ़ ली हमने यार, strain energy method हो गया already, right? If you have two-hinge parabolic arch and a point load is placed on the arch exactly at the crown, then the value is 25 by 128 WL by H. Please remember this value, guys. I'm just showing the values once so that you can recall it. Okay, that is our main purpose. 25 by 128 WL by H. Now if a UDL is placed on the entire span, then what should be answer? If a UDL placed on the entire span in case of 2-hinge parabolic arch, the answer will remain same. There is no change. WL square by 8H, WL square by 8H, WL square by 8H. And in this case also, the same condition is applicable. Bending moment at any section is always equal to 0, right? Okay. Next one. When half of the parabolic arch is loaded by UDL, I will explain this case and this case on this particular slide. Let us suppose a half of UDL is there, guys, or we have UVL part. We have UVL part like this. UVL part like this, or UDL like this, half of the UDL, right? So in this case also, the reaction will become half, which will be equal to how much? WL square by 16H. WL square by 16H, which is half of the previous one, right? Which we have discussed. Please remember these values, guys. These values can be asked directly in the examination, right? And you know that how to solve it because we have discussed one of the formula. Just you have to use that so that you will get the answer. But guys, these are the standard case they will ask in the examination directly. So if you remember the values, then it will be more beneficial for you. You are able to take the answer directly without solving it. Okay, that is my recommendation. Crystal clear, guys? Please remember these standard values which can be asked in the examination. Now, effect of temperature. Now guys, you know that due to the change in temperature, we may have certain horizontal reaction which can be developed in case of 2-hinge arch, in case of 3-hinge arch, right? So please remember the values again. For 2-hinge arch, please remember these values. If 2-hinge arch is there, which is semicircular, then what should be the horizontal thrust? What should be the horizontal thrust value? Please remember this. Horizontal thrust is equal to 4 EI alpha delta T by pi r square. If you are able to remember it, then please remember it, guys. Otherwise, you can leave this particular part of effect of temperature from the arch portion. That is my suggestion, right? For 2-hinge parabolic arch, the value will be 15 by 8 EI naught alpha delta T by h square. This is for parabolic. This is for semicircular. Please remember these values, okay, due to change in temperature. Crystal clear? Okay. Now guys, let's start the next chapter, which is basically our cable. Let's understand the next portion, which is cable. Now from cable, you can expect the question. From cable, you can expect the question in the GATE examination. From arches, it is very less chance, but still if you have question, then it can be a standard case, right? And that's why I have suggested you, please remember the values directly. Now in cable, guys, certain key points are there which you have to remember. First, the internal reaction which can be developed in the cable is only axial tension, right? That means a cable can bear the tension force only, right? At any point on the cable, the bending moment is equal to how much? It should be equal to 0. Now the shape of cable, very important. 3 cases are there. Now, if a UDL is placed on the span length of the cable, let us suppose this is our span. Span is nothing as, it is the horizontal distance between the support is known as span. The horizontal distance between the support is known as span. So guys, if the span length is this, let us suppose L, and UDL is W kilonewton per meter, right? So in such condition, the shape of cable is parabolic. Please remember this. But let us suppose if the UDL is placed on the length of cable itself, on the length of cable itself. So in such condition, this should be catenary shape. Catenary shape. Please remember this. Third condition, if you have point load like this, so such type of shape is polygonal shape or funicular polygonal. फनिकुलर पॉलीगोनल शेप। क्लियर, प्लीज रिमेंबर दीज। सर अगर मैट्रिक्स नहीं पढ़े तो गेट के लिए स्किप कर सकते हैं वो चैप्टर। धनुष कर सकते हैं, ऐसा कोई दिक्कत नहीं है, बहुत रेयर चांस होता है कभी पूछ ले, बट जो मैं फंडामेंटल बताऊंगा उस फंडामेंटल से आपका काम हो जाएगा, तो उतना तो पढ़ ही लो, है ना, ये मेरा सजेशन है, बाकी आपकी विश। ठीक है, okay guys, so this is parabolic, this is catenary, this is funicular. Please remember this condition. If you have a UDL on the span length, then it is parabolic. If the UDL is placed along to the length of cable, along to the length of cable, along to the length of cable, then is catenary. Point load is there, that is funicular polygonal, right? Now guys, wait a minute, let's solve certain condition. Now please remember certain condition guys in case of cable also. Let us suppose if we have a parabolic cable and a UDL is placed on the entire span W, right, kilonewton per meter, and this length is L. Now guys, in this particular case we have reaction which should be like this. We have reaction which should be like this, and this is basically our dip. This is known as dip. This one is H, right? So value of VA is how much? Value of VA is equal to how much? Value of VA is equal to WL by 2. VB is equal to how much? Again WL by 2. This is HA, this is HB. So HA is equal to WL square by 8H. Please remember these values. You can find it out also. WL square by 8H. Now the question is, where maximum tension will occur? Maximum tension will occur at the support. Please remember this. This is basically T max. Maximum tension is nothing as our resultant reaction at the support. That is our maximum tension. And where you will find the minimum tension? At the mid span. So at this location you may find minimum tension. Minimum tension. These are the certain key concept guys which you have to remember always. Okay, so T max, what is the value of T max? T max is nothing as, it is the resultant reaction of vertical and horizontal reaction, which is basically VA square plus HA square. So it is equal to how much? VA square. VA is equal to how much? WL by 2 whole square plus HA square, WL square by 8H whole square. So this is T max. What is the value of T minimum? T minimum is equal to HA itself. Kindly consider, if you break the structure from the center, right, then T minimum will be equal to HA itself, and it is equal to WL square by 8H. Please remember these values. This is T minimum and this is T max. T max. Okay? Okay guys. Next one more thing guys which I want to suggest you. Let us suppose if you have different level of support. One is this, second is this. Getting a point? And again, this is our span L1, this is H1, this is H2, and this is L2. All of you know these concepts or not guys? Just we are trying to recall it. Yes or no? Please let me know, right? Let me know this condition guys, whether you know this or not. Have you solved such type of cases or not guys? Please write down. Have you solved these type of cases? Yes. That's why just we are trying to brush up it, right? Yes. Okay. Very nice. Okay. Very nice. Then only you are able to understand guys. Otherwise, if you have learned the subject at least once, then it will be more beneficial for you. If you are learning this particular thing for first time and you just want to solve certain question in the GATE examination from the structure part, then also it can be beneficial, but you have to memorize certain things, right? Okay. Prashant, no. Oh ho. So Prashant, what you have to do, listen. Acha, Prashant, tell me, do you know how to find out the vertical reaction and horizontal reaction? Do you know that? How to find out vertical reaction and horizontal reaction in this case? Do you know that? How many of you do not know this? How to find out vertical and horizontal reaction? Please write down the chat box. Then I will solve this. कितने बच्चों को नहीं पता? No one is writing. Only Prashant is saying, sir. No, sir. Okay. So Prashant, what you have to do basically, just you have to use the summation Fy0, summation Fx0. Then you have to consider summation moment at B is equal to 0. You will get the value of Va, Vb. Then please consider moment at this particular point is equal to 0, either from the left portion or the right portion. You are able to find out the HA and HB value. Understood? Now, please remember this point. The maximum tension in this particular cable will be at support and the minimum tension will occur at the center, or you can say that at the bottom one or at the bottom point. This is the location where minimum tension will be there. Let us suppose if you want to find out tension. Okay, Prashant, let me explain one point. Okay. Let us suppose if you want to find out the tension in this particular cable at any distance x. So what is that value? Very easy. Just try to draw this tension line, tension force like this. And the angle will be like this, which is our theta with respect to horizontal. And this is our dip, which is basically y. Right? Now guys, at this particular location, we have VA and this is HA. So what you have to do, you have to just write summation Fx is equal to 0. So T cos theta minus HA is equal to 0. Now tell me T is equal to HA by cos theta. Yes or no? Now Prashant, tell me if cos theta is minimum. Listen carefully. If cos theta is minimum, T will be maximum. Okay, Prashant. Tell me if cos theta is lesser, then only T will be max. But if cos theta is higher, then T will be minimum. Yes or no? So where you will get theta higher, where you will get theta value is higher? Tell me guys. Theta is maximum, theta will be maximum at support. Theta is maximum at support. If it is maximum at the support, so we know that cos 0 is 1, but cos 90 is 0. That means if we have theta more, then cos theta will be less. So theta is maximum, then cos theta will be minimum. If cos theta is minimum, then T is maximum. Simple, right? But let us suppose if theta is minimum and it will occur at the midspan, right? That means what? Theta is minimum. That means at this location, you may have theta is equal to 0. Why? If you draw a tangent like this, then what should be the angle of this tangent with respect to horizontal? It is 0. So that's why guys, if theta is minimum at midspan, then cos theta is what? Greater, because cos theta will become 1, right? If cos theta is greater, then T is minimum. Getting a point? Clear? Okay. Now let's move to the next condition, guys. If you have different support level, so guys, in such condition, the maximum tension will occur at the higher support level. Please remember these concepts, right? Whatever I am saying, it is very, very important over here, guys. This is our T max. Please remember at higher level of support, at higher elevation support, the maximum tension will occur. T max will occur at this particular support as a resultant, right? One more point which is very important. Do you remember guys, there's one relation for parabolic condition, let us suppose this is x, and this one is y. Now can I say that our equation will be what? For two value of x, that means x square is proportional to y. So we can write here x square divided by y should be constant. So the same concept we can apply for the above condition. This is our x, that means L1 square divided by H1 is equal to L2 square divided by H2. This is one of the relation which you can use to find out the value of L1, L2 or H1, H2. Second relation is L1 plus L2 is L. So these are the relation which you can use in your problem solution, right? While solving the problem, sometime we have to use these equations to find out the value of either H1, H2 or either L1, L2 and etc. So please remember these equations. Clear? Any doubt up to this? Then we'll start ILD. Last two chapter. Then we'll start ILD. Clear? Okay. Now let's start the ILD part. Now what is ILD? ILD is nothing as, guys, as you know that in our structure, if you apply a certain action, then we may have some response, and that response may be in the form of internal reaction, external reaction, slope and deflection values. Now the question is, if I have a live load, what do you mean by live load? Live load can move from one point to another point, right? That is basically live load. So let us consider if we have a live load which is moving from one point to another point, right? So let us suppose this load is trying to move from this point to this point right now, like this. Correct? Now the question is, if the load is moving from one point to another point, then what should be the variation? What should be the variation? Listen carefully. What should be the variation of vertical reactions, horizontal reaction, internal reaction, slope and deflection? That is to be known as ILD. That is to be known as ILD. Let's take one example. Let us suppose if I want to draw the ILD for vertical reaction VA, which is this one. Right now load is at this location. Then what is the value of VA? Tell me, guys. If load is placed at this location, then what is the value of VA? Please write down. If load is placed at this location, then what is the value of VA? It is equal to load value. That means 1. It should be 1. If load is placed exactly at midspan, then what will be the value of VA? It should be 0.5. If load is placed at this location, then the value of VA is equal to how much? It should be 0. So what we are trying to do? We are trying to write down the value of reaction or the stress function when the position of load is changing. And that particular variation, if you want to represent, is nothing as our ILD. That is nothing as our ILD. Getting a point? Clear? That is nothing as ILD. So it is the variation of a stress function like axial force, shear force, bending moment, slope and deflection at a point due to the unit concentrated load or movement moves from one end to other end of the structure, and that is nothing as our ILD. Now guys, there are two possibilities. Either we will have unit load or we can have unit moment, but the dimension of these values will not be there. That means they don't have any kind of dimension like ton, kilonewton, right, kg and etc. These type of dimension is not there, only one. Getting a point? Okay. Now let's understand, guys, the type of ILD. Basically there are two type of ILD which we have. One is quantitative and second is qualitative. Quantitative ILD and second is qualitative ILD. Qualitative ILD. What is quantitative? In which value and shape both are known to us, right? Qualitative ILD means only shape shape of ILD, only shape of ILD, right? That is qualitative, correct? Now, the question is, if I want to find out the quantitative ILD, then you have to go with the numerical approach. Please prefer numerical approach. Numerical approach to find out the ILD, right? But let us suppose, guys, if I want to draw the qualitative ILD, then you have to use Muller Breslau principle, which is mostly used in your examination. Breslau principle, right? In GATE examination, they are just trying to plan the question which can be solved by Muller Breslau principle mainly, right? So you can use it. Now the question is, sir, let's understand how to draw the ILD. Arey baba. By numerical approach and Muller Breslau principle. We will discuss both of them, right? Wait a second, guys. Why it is get crash? Just a second, right? Sir, can we draw ILD for every structure? Yes, Dhanush, you can draw the ILD for like determinate structure or indeterminate structure both, right? You can draw the ILD for both the type of structure, whether it is determinate and indeterminate, right? Now, let's understand, guys, how to draw the ILD, right? Let's understand one of the case by numerical approach. How we can draw the ILD by numerical approach. Numerical approach. I'm just explaining the numerical approach little bit over here, guys, so that you can recall it very easily. Let us suppose this is our structure. This is support A, this is support B. We may have vertical reaction over here, VA, VB, and HA. So guys, let's draw the ILD for VA. Okay. We will understand some of the cases so that you can understand the approach over here. Right now, this is our unit load. So we have to consider the unit load distance from a point. Let us consider this is basically X. So we need to find out what should be the variation of VA over here, right? So guys, very simple. First, we will write summation moment at B is equal to 0. So VA into L, let us suppose span is L, minus 1 into this distance is L minus X. So L minus X is equal to 0. So the value of VA is equal to how much? It will be L minus X divided by L. And that is the value of VA. Now guys, the value of X is what? Anyone who can tell me? X is what? It is the distance of section or it is the position of unit load? Please write down. It is the distance of section or it is the position of unit load? Please write down. Position of unit load. Very nice. It is the position of unit load. Please remember, it is the position of unit load. Position of unit load. Position of unit load. Very nice. Very nice. So guys, in this case, can I say that X can vary from 0 to L? Right. So when X is equal to 0, VA is equal to how much? If X is equal to 0, VA is equal to how much? It is equal to 1. If X is equal to L by 2, VA is equal to how much? L minus L by 2 divided by L by 2. It should be 0.5. If X is equal to L, VA is equal to how much? It should be 0. Kindly see this. Correct? Now guys, if you draw this variation, what do you feel? The value of VA is 1 when X is equal to 0. When X is equal to L by 2, this value is 0.5. When X is equal to L, VA is equal to 0. So this is nothing as this is the ILD for VA. Getting on? In the same way, we can draw the ILD for VB also, right? What should be our variation for VB? If you solve this, you will get VB is equal to X by L. So our ILD for VB will be like this. Yes or no? this value is 1, this value is 0.5, and this is our ILD for VB. Correct? Okay. Now what is the ILD for shear force at C? What is the ILD for shear force at C? Let us suppose if we take a section, over here C at a distance of A and at a distance of B from support B. This is A, this is B. So guys, what should be our ILD for shear force at C? It should be like this. This is negative, this is positive, this value is A by L, this value is B by L. And this is nothing as ILD for shear force at C. Let us suppose if I want to draw the ILD for bending moment at C, then what is the ILD for bending moment at C? It should be like this. And this ordinate is positive and it will be AB by L. And this is the ILD for bending moment at C. Yes or no? Tell me guys. I think you have solved these type of concept or not already. Getting a point? So in this way you can do the numerical approach. In this way you can recall the numerical approach easily. Correct? Now let's understand the next approach, which is basically the Mueller Breslau principle. So as per Mueller Breslau principle, we are able to develop the shape of ILD only. Only the shape of ILD we are able to predict, right? In this case, we will not get the values. Second, due to unit load only, we are able to draw the ILD, not due to unit moment. Second, third point, it is valid for determinate and indeterminate structure both. Whether it is determinate structure or indeterminate structure, we are able to develop it. Now the question is, what is the statement of ILD? What is the statement which is given by Mueller Breslau principle? So let's understand by having some example only. Okay, let's take some example to understand the concept. So first we will draw the ILD for determinate structure. So guys, let us suppose if I want to draw the ILD for VA. If I want to draw the ILD for, not VA, let us suppose if I want to draw the ILD for shear force at C. If I want to draw the ILD for shear force at C. So as per Mueller Breslau principle, you have to release that particular reaction. If you release that particular reaction, that means we need to use guided roller, right? And the net unit displacement which we have to give is 1. So you know that guys, this left portion move downward, right portion should move upward. Why? Because we have the shear force on this particular part also, on this particular part also. And the net displacement is equal to how much? That should be equal to 1. So guys, this is our deflected shape of the structure. This is negative, this is positive. And this one is Y1 and this one is Y2. So Y1 plus Y2 is equal to how much? It should be 1. Getting a point? Okay. Next one, let us suppose if I want to draw the ILD for VB reaction. So as per Mueller Breslau principle, you need to remove that particular stress function, or you need to release that particular stress function for which you have to draw the ILD. So I am removing the VB reaction over here. Give unit displacement in the direction of that particular reaction. That means delta is equal to 1. And judge the deflected shape of the structure. So this is our ILD for VB. This is ILD for VB. Getting a point? This is the ILD for VB part. Crystal clear? Okay, very nice. Now guys, if I want to draw the ILD for bending moment, at C, so you have to put a hinge. That means I need to release the reaction of bending moment and give unit rotation like this. So our deflected shape of the structure will be like this, right? So the net rotation will be equal to how much? The net rotation is equal to 1, sir. This is theta 1, this is theta 2. So theta 1 plus theta 2 should be equal to 1. And this particular ordinate, we already know that it is AB by L. Y is equal to AB by L. Clear? So this is the approach. That means, let me read the statement. So if you want to draw the ILD for any stress function like axial force, shear force, bending moment, so it can be obtained by giving unit displacement in the direction of that stress function and just the deflected shape of the structure, right? That should be your approach to find out the ILD. Okay, Shiva, I will explain the diagram. There is no problem. I will explain once how we can draw the ILD. Once again, I will explain it. Okay, let's use a separate page in which I will discuss it. Let us suppose, Shiva, we need to, before the diagram, which one? Which part, Shiva? Sky. Tell me, Shiva Kumar Yadav. Sky again, right? So tell me, what is your doubt exactly? Okay, you are not able to draw the diagram. Let's discuss it in little bit detail. Okay, let me explain. Shiva, listen, and other student also. Let's use the Mueller Breslau principle. Let us suppose this is the structure which is given to us, and I want to draw the ILD for vertical reaction VA. Vertical reaction VA as per Muller Breslau principle. Now what do you have to do? As per Muller Breslau principle, first you have to release that particular reaction for which we are trying to draw the ILD. Right now we are drawing the ILD for VA. So we will release it or we will remove it. If you remove it, then only one reaction can act over here, which will be horizontal. So in such condition, you need to draw a support which is basically a roller, which should be like this. Then only horizontal reaction will be there, but vertical reaction is equal to 0. Getting a point? Horizontal reaction will be there, but vertical reaction is 0. Okay. Now this one is VB. Now, second step, give unit displacement. That means delta is equal to 1. If you give delta is equal to 1, then the deflected shape of the structure will be like this. If you give delta is equal to 1, then this particular shape you may get after giving delta is equal to 1. And what is this? This is nothing as ILD for VA. This is nothing as ILD for VA. Getting a point? Similarly, if you want to draw the ILD for VB, release that particular stress function. Now tell me, if I remove the VB, then this particular end will become free. If it will become free, I need to apply delta is equal to 1. If you apply delta is equal to 1, then the deflected shape of the structure will be like this. So what is this basically? This is again ILD for VB. ILD for VB. Yes or no? Arun and Shiva, write down. Now tell me, are you able to understand? Or still, if you have doubt, please write down, guys. I will explain it once again. There is no problem. There is no issue. If you want to ask, guys, anything, you can ask over here. I will explain because it is my responsibility, right? I will explain. There is no problem. So any doubt, Shiva, any doubt, Varun, any doubt, Prashant, if you have, please write down. It is crystal clear to you or not? Why we are applying delta is equal to 1? Because it is written in the Mueller Breslau principle. For any stress function, if you want to draw the ILD, you need to release that particular reaction. If it is a linear reaction, then you have to apply the linear displacement. If it is an angular reaction, then we have to apply the angular displacement. For linear, delta is equal to 1. For angular, theta is equal to 1. So if you apply delta is equal to 1, then means now you are able to understand why we are applying delta is equal to 1, because it is written in the Mueller Breslau principle itself. We need to give delta is equal to 1, that means unit displacement. So the deflected shape of the structure which we are getting is basically ILD. Significance. What is the significance? Okay. So let us suppose this is the ILD for VA. This is the ILD for VA. Now actually, what is the meaning of this particular shape, and why we are means what is the value of ordinate over here, guys, which we are trying to represent? Let me explain. Let us suppose, guys, if you have a load which is placed at a distance of 5 meter from this particular end, and it is basically 8 meter from this end. Now I want to calculate what should be the value of reaction of VA. What should be the value of reaction VA? How we can calculate? Very simple. Listen, guys. So as per ILD, let us suppose if you have a distance x, if you mark over here, then the ordinate which we are representing is basically the value of, or the reaction value of VA, when the unit load is placed at this particular distance x on the actual structure. Getting a point? Listen once again. Let me change it. Let's make 10 meter so that it will be more easy to understand, okay, in terms of values. So guys, this is total 15 meter. Clear? So let us suppose, just imagine if on the actual structure, if you have one unit load, if one unit load is there, so at x is equal to 5 meter, what should be the value of y? Can you calculate it? What should be the value of y? Can you calculate it? Can you calculate it? What should be the value of y? At x is equal to 5 meter, what is the value of y? Guys, at 15 meter, it is 1. At 15 meter, it is 1. Then at a distance of 10 meter from this particular end, what is this value of y? Can we calculate? Yes. At 15 meter, the value is 1. At 10 meter, the value is y. So y is equal to how much? It should be 10 by 15. Now what it actually represent? It means if unit load is present at a distance of 10 meter from the right support or 5 meter from the left support, then the reaction VA is equal to 10 by 15. The reaction VA is equal to 10 by 15. So guys, due to unit load, if this much amount of reaction is there, if you have 10 kiloton load, then what should be the reaction? So reaction is equal to load into ordinate. So 10 into 10 divided by 15, you will get your answer. In this way you can calculate. And now you are able to understand the significance of it. Kilonewton. Yes or no, Ashish, Arun and Shiva? Okay, done. Now let's move to the next thing, guys, which is basically our indeterminate part. Okay, let's understand the ILD for indeterminate portion also. This is fixed support. This is fixed support. This is A. This is B. Okay. Now, let us suppose if I want to draw the ILD for VA reaction, for VB reaction, for MA reaction, for MB reaction. We'll draw it in a complete way right now. Okay. So that everyone can understand each and everything. This is VA, this is VB, this is MA, and this is MB, which we have to draw. That is our main task. Now, as per Mueller Breslau principle, I need to remove, you know that guys, in this case we have horizontal reaction, but that horizontal reaction ILD will be 0. That's why we are not considering it. Or if you consider vertical load, you know that guys, the horizontal reaction will not develop. Getting a point? The horizontal reaction will not develop. So as per Mueller Breslau principle, if you want to draw the ILD for vertical reaction VA, kindly remove it. If you want to remove it, then this particular support will be a vertical guided roller support and it will remain fixed. Now give unit displacement, that means delta is equal to 1. If you give delta is equal to 1, then the deflected shape of the structure will be like this. And it will be curvy. It will be curvy. So this is what? This is basically the ILD for VA. ILD for VA. Usually they will ask the question which is based upon Mueller Breslau principle only. That means Mueller Breslau principle, but for the determinate structure. If it is for determinate structure, by drawing means if you draw the ILD by using Mueller Breslau principle, still you are able to find out the values in case of similar triangle concept, or by in case of triangular shape, in case of rectangular shape, and such type of condition you may find in the determinate structure. So that's why guys, it is very useful to use the Mueller Breslau principle in the GATE examination, but by using the concept of mathematics or geometrical shape, we are able to find out the values also. But it is not said by the Mueller Breslau Sahab. Getting a point? Okay. Now this is the ILD for VA. Now let's draw the ILD for MA. Let's draw the ILD for MA. Now anyone who can tell me guys, if I want to draw the ILD for MA, then which type of support I have to use? Anyone? Which type of support I have to apply at support A? Hinge. Very nice. We need to use hinge support. We need to use hinge support. So what you have to do guys, give unit rotation in place of unit displacement. Now what we have to do, give unit rotation in the direction of MA. So in this way, we have to apply theta is equal to 1. So this is our deflected shape of the structure. Getting a point? So this is what, this is basically our ILD bacha, ILD for MA. Getting a point? So in the same way, you will get the ILD for MB also and VB also. Let's draw the ILD for VB part first. So for VB, again, we have to release the reaction, then apply delta is equal to 1. And the deflected shape of the structure will give us the ILD for the stress function. Kindly join this. Like this. And this one is 1 plus, and this is what? ILD for VB. In the same way, we can draw the ILD for VA also. So ILD for MB also. So this particular support will become hinge now. Now you have to give theta is equal to 1, correct? So this will be theta is equal to 1, right? And the deflected shape of the structure will be like this. So this is our ILD for MB. Getting a point? ILD for MB. Now tell me guys, it is clear? Very nice, very nice, very nice. Superb, superb, superb. Clear. Okay. Now similarly guys, let us suppose if I want to draw the ILD for bending moment and shear force at a section C. So this is distance A, this is distance B. So let's draw the ILD for shear force at C and bending moment at C. So guys, for shear force at C, you need to break the structure, right, at section C itself. Now, in this case, why we are using two arrow? Tell me guys, if you take a section on the left part also and on the right part also, we may have the shear force. And that is the reason due to which you have to use this standard direction. Please remember this is a standard direction. The left portion should move upward and the right portion should move downward. Getting a point? Oh, sorry. I think it is opposite. This one is opposite. Left portion downward, right portion upward. Clear? So this one is our deflected shape of the structure. But in this case, we are not able to find out the values. The reason is the shape is curvy, right? The shape is curvy. So this one is y1, this one is y2. So y1 plus y2 is equal to 1. And this is basically our ILD for shear force at C. Now similarly, if I want to draw the ILD for bending moment at C, what I need to do? I need to release that reaction by making it hinge, internal hinge. After putting our internal hinge, give unit rotation. So this part should be like this part should be like this. These are the standard direction which you have to remember for internal reaction. Okay. Now this portion will move like this portion will move like this. Again, our theta 1 and theta 2 addition will be equal to 1. And this is basically our ILD for bending moment at C. Now I think you are able to recall it, right? Getting a point or not? Any doubt up to this, guys? Up to this, any doubt? Okay. Now, what is the application of ILD basically? What is the application of ILD? There are basically two applications of ILD. One is, if you know the ILD, then it is very easy to find out the value of a stress function. In the previous case, we have already discussed, if you have 1 unit load, then what is the value of VA? If you have 10 kilonewton load, then what is the value of VA? We have done that particular calculation. So to find out the value of a stress function for a particular given load system, then that is the one of the application which we have to use. Are you getting a point? To calculate the total value of a given stress function due to different loading condition. What should be the value of a particular stress function if you have a different load system which is applicable on the structure, right? Second one is, guys, if I ask you, so please take on toughest structure example. Toughest means what? Kindly understand these points. If you are able to understand these points, then you are able to solve any question, right? There is no problem. Okay. Now listen guys, let me ask you one question. Guys, if you see the ILD of a structure, let me show you that. Let us suppose this is VB. Okay. Now anyone who can tell me guys, what should be the location of our support reaction? Oh, sorry, what should be our location of unit load so that the value of VB is maximum? That is my question. Tell me guys. This is x is equal to 0 and this one is x is equal to L. Tell me guys, where you will put your unit load so that the value of VB is equal to maximum? Tell me guys. X is equal to L, right? So how would you know that this should be the position of load so that the VB value will be greater? Listen Tiksha, please understand, if you put the unit load exactly at B, then only the value of VB is higher. then only the value of VB is higher, right? So the question is, how would you know? Because you can see the ordinate. And that's why, guys, this is the second application which we need to discuss to find out the position of load when our stress function will be maximum. What should be the location of our load so that our stress function should be maximum? So this is another part of application. Clear? Getting a point? Now, which type of cases you can expect in the GATE examination? So let's discuss it in detail. Okay. Listen, guys, one of the cases basically, wait a minute, let me show you this, then you are able to understand this. Guys, basically, if you talk about the effect of moving load, there are basically two type of loading condition. One is basically UDL and second is wheel loads, or you can say that the point load. One is UDL, second is point load. UDL, in case of UDL, guys, let us suppose this is our UDL. Let us consider this is head. Why it is head? And this is tail. Why it is tail? Why? Because the direction of movement is this, which means left to right. If the direction of movement is left to right, then this is head and this is tail. And if it is opposite, that means it is moving right to left, then this one is head and this is tail. Let us consider this is the length L dash. That means length of UDL is L dash. And let us suppose if we have a structure whose span length is L, whose span length is L. So guys, there are two situations. Length of UDL is shorter than span length. Length of UDL is shorter than span length. That means length of UDL, L dash is less than L. In this case, L dash is greater than L. Getting a point? Length of UDL is greater than span length, and this is shorter than span length. There are two more. There are second case, which is basically point load. So it may be possible we may have single wheel load. It may be possible we may have multiple wheel loads. That means two wheel load, or it may be have series of wheel loads. Right? So what you can expect, guys, in the GATE examination, they can ask the question which is related to the UDL part, or either from your point load, but from single wheel load or two wheel load system only, right? They can plan the question from these two part, and the UDL part is very important. Okay, so let's discuss it, guys. What is basically how we can solve the problem which is related to it. Now you already know that, guys, this is the ILD. This is the ILD for VA, yes or no? And this is the ILD for VB. This is the ILD for VA, this is the ILD for VB. Now tell me, guys, what should be the location? Listen very carefully, then only you can understand. What should be the location of your UDL so that the maximum value of VA can be developed? Tell me, guys. You know that what is head, what is tail. This is A, let us consider this is point B. So guys, what you have to do? Can I say that I need to put tail at A so that the maximum area of ILD can be covered under the UDL? Please write down yes or no. I need to put the tail at A. Tail at A so that the maximum area can be covered, right? So what should be the value of VA in this case? VA equal to the UDL intensity, which is kilonewton per meter, multiplied by area. What is this area? Area under the UDL. Area of ILD under the UDL. Area of ILD under the UDL. Under the UDL. Getting a point? Similarly, this is ILD for VB. So can I say that head at B? Head at B. Head at B, then we are able to get the maximum area of ILD under the UDL. Please remember, in case of UDL, you have to multiply with the area of ILD. If you have point load, then you have to multiply the ordinate. Clear? Okay. Next one, for negative shear force and positive shear force. For negative shear force, ILD for shear force at C, right? But this particular condition will be valid for maximum negative shear force at C. So guys, can I say that head should be present just left of C? Head just left of. Sir, need break for dinner. Listen, Prashant, another student, you can take your dinner, but guys, I think I need only half an hour to complete this particular marathon. So it will be much better if we take it in a right now, means if we complete it right now, then it will be much better. If we take a break, then it will become like 2 hour session more, right? So if you are comfortable, then let me know, guys. I will make it short and sweet so that you can complete it early. I will tell you the only important things right now, just only important things. Okay. Okay, guys, let's complete this. Then you can take a break, like half an hour more needed, right? After that, we'll close it. Okay, right? So just you have to revise the concept, guys. We are just revising the concept, right? I'm not going into the much detail, because if I go into the detail, then it will be a subject explanation, as well as we are not able to complete it, because each and every chapter will have a like own means own duration, right? If I want to explain the ILD itself, guys, I need 20 hours. Can you imagine? I need 20 hours to explain the ILD only in detail. 20 hour means like ILD part, effect of moving load, effect means each and every part I have to discuss. So in that particular discussion, I need 20 hours for only ILD portion. So guys, you can expect, you can understand, if you want to revise the subject, then it is much beneficial, right? This particular marathon, right? But if you are learning the subject first time, then is my suggestion, guys, you can use it to be true. You can use this particular session, but it can give you 50% benefit to be true. 50% benefit, like 50% of the concept you can understand, but 50% of the concept will not be understood by you if you are learning this subject first time. That is my suggestion, right? And my opinion also. So guys, if you're learning the subject first time, then this particular marathon give you 50% benefit only. Or you can say that, let us suppose if the 5-mark question you can expect in the GATE examination, you can score 2 mark or 3 mark from this particular marathon, because this is, you can say that this is basically a half knowledge, right? Not half knowledge, it is a complete knowledge for those who have already learned the subject, but it is a half knowledge for those student who has not completed the subject at least one, एक बार भी कंप्लीट नहीं करा है, तो उनके लिए आधा नॉलेज है. मैं हमेशा सही बोलता हूँ बच्चों, मैं कभी झूठ नहीं बोलूंगा, घुमा फिरा के नहीं बोलूंगा. अब आपको लाइव देखना हो देखो, नहीं देखना है उससे कोई इशू नहीं है, बट आई विल ऑलवेज टेल यू द ट्रुथ, right? So now you can understand it, right? That's why I'm explaining in just this way, so that those students who know the concept, they are able to apply it. Okay, now guys, listen carefully. Okay, now let's understand, guys. The next one is what? Maximum positive shear force. So you have to put the tail at just left or just right of C. We can write here, guys, tail just right of C. Getting a point? Just right of C. This is maximum positive shear force. Maximum positive shear force at C. Okay. Next one, let us suppose if we have maximum bending moment at C. Maximum bending moment at C. So maximum bending moment at C, for maximum bending moment at C, what you have to do, guys, you have to put the UDL in that manner so that the length of UDL will get divided in the same proportion as the section C is trying to divide the structure. Let me show you that. Let us suppose this is our structure and this is section C, which is trying to divide the structure like in a proportion of A to B. So you need to put the UDL so that this section C will try to divide the length of UDL in the same proportion like this, right? So guys, this should be our ratio. A dash by A is equal to B dash by B. Getting a point? And just you have to cover the area under the UDL, multiply by UDL intensity, you will get your answer. Clear? Next. Next one is basically the absolute maximum values. Now these are what? These are the maximum value of bending moment at a particular section. This is maximum negative shear force at a particular section. This is maximum positive shear force at a particular section. But let us suppose if I want to find out absolute maximum positive shear force, absolute maximum negative shear force, absolute maximum bending moment, then what should be the location? Let me explain. So for absolute maximum positive shear force, the section is to be decided by us, right? Let me hide myself. So for absolute maximum positive shear force, what should be your section? The section should be just right of A, just right of A. It should be just right of A. This is the location for absolute maximum positive shear force. Now tell me guys, this particular portion will have zero ordinate, but this particular portion will get complete ordinate because this is just right of A, just right of A, and this section is decided by us, just right of A. So this should be our ILD. Tell me guys, yes or no? Y1 will be equal to 0, but Y2 is equal to how much? Y2 will take complete ordinate, but Y1 will be equal to 0 because this distance is very less. Getting a point? So this is our absolute maximum positive shear force. Now tell me guys, for absolute maximum positive shear force, what should be the location of your UDL? It will be same as VA. That means the tail should be present at A itself. Tail at A. Clear? Similarly guys, for absolute maximum negative shear force, absolute maximum negative shear force will occur just left of B, So this should be our deflected shape of the structure. So this is minus and this one is 1, right? Either you can represent in this way also. Now, in this case, head at B, and this is our absolute maximum negative shear force. Clear? Next one. Absolute maximum bending moment. Now, absolute maximum bending moment will occur mid-span. At mid-span in case of UDL. So if it occur at the mid-span, so what you have to do guys? You have to break the length of UDL equally on both the side. That means this value should be L dash by 2. This value is also L dash by 2. And the absolute maximum value you will get at the mid-span itself. Getting a point or not? Crystal clear to all of you or not? All of you are able to understand guys? Shorter than length of the span. If it is shorter than the span length, then what are the cases? Now, listen guys. Just imagine this one is done, right? Now let us suppose if the length of UDL is greater than span length, then what you have to do? Very simple. Just extend the UDL on the complete ILD. Nothing else. Listen guys, you have to consider complete UDL on the complete ILD. Getting a point? That means the UDL will cover the complete ILD area and multiply it. you will get the same thing, or you will get your answer, right? In this case, complete UDL is complete ILD is covered. In this case, if you want to calculate absolute maximum, sorry, maximum positive shear force, cover only positive area completely. In this case, cover negative area completely. In this case, cover negative area completely. In this case, cover entire area. 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 That's it. Done. Getting a point or not? Are you able to understand? All of you. Okay. All of you, please write down. Okay. Now guys, if you have a single wheel load, so it is very, very easy case. If you have single wheel load, then in single wheel load condition, listen guys, if you have a single wheel load condition, this is done, this is done. If you have single wheel load condition, what you have to do? You have to put the load exactly at the maximum ordinate. That means if I want to find out the maximum value of VA, I will put the load exactly at maximum ordinate. Yes or no? At this location. For VB at this location. For shear force, negative shear force at C at this location. For positive shear force at C at this location. For maximum bending at C at this location. For absolute maximum positive shear force at this location. Absolute maximum negative shear force at this location. Absolute maximum positive bending or absolute maximum bending moment at this location. Tell me guys, for single wheel load, are you able to recall it? We have to just revise it, right? So tell me guys, yes or no? Praveen, I have already sent the means you can say that this particular content to the course team, and I think they will plan it in the January month itself. I have already sent the mail to the course team so that they can plan these chapter, because still remaining in the course, right? So that we will discuss in the January month itself. So I think we will have the class as soon as possible. I will tell them again so that they will plan it. Okay, Praveen? In the last month itself, I have sent the mail, right? Sorry for the video. Praveen, we have already, means I have already sent the mail to the course team and they will plan it. Okay. Dynamic in the structure part, I think I have already covered it. Praveen, we have covered it. The dynamic portion means free vibration and the force vibration we have already done. Free and the force vibration is already done in the structure analysis part, Praveen. Okay, Praveen, what you can do, kindly mail me. I will check it out. In which batch you are saying, right? I think it is already done, right? The dynamic portion. Yes, it is already covered. Dynamic portion is already done, but the RCC means in the RCC we have only 3 chapters, which is still remaining, like your retaining wall or like something which is mainly important for the EAC examination, right? So these chapters we will plan in the January itself so that it will be completed. Okay. 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 Now guys, the next thing which we have to discuss is basically two-wheel load system. Now in two-wheel load system, which particular case is most important that we are discussing? Guys, they usually ask to find out the absolute maximum bending moment. So let us suppose this is our P1 load, this one is P2 load. And let us consider MCQ सीरीज में, ये कौन सा है भाई MCQ सीरीज में, मुझे आइडिया नहीं है वरुण इसके बारे में, एक बार हम देख लेंगे बच्चे, ठीक है, ठीक है. So let us suppose this is distance Z. So now what you have to do, first of all, you need to find out the CG of the load system. Okay. CG of the load system. This is the most important case which can be asked in the GATE examination mostly. CG of the load system. How you can find it out? CG of the load system. So how you can find it out? Let us consider the CG is placed at a distance of Z1 from P1. So what we will write, guys, we have P1 into 0 plus P2 into Z1 plus Z2, or you can write it Z also, divided by P1 plus P2. So you will get the value of Z bar, but this Z bar is nothing as our Z1 itself, right? In this way, you can find out the CG of the load system, right? Now, let us consider P2 load is heavy as compared to P1, right? This is our CG. Now, let us consider P2 load is heavy as compared to P1, as well as this load is nearest to CG, and this one is next nearest to CG, next nearest to CG, right? So how you can find out the absolute maximum bending moment? What you have to do? Kindly mark the center of the structure. This is our center of the structure. Now you need to take this particular distance, which is basically Z2, which is in between heavy load and the nearest load to the CG, right? And the CG, right? This is the distance which you have to take and put it exactly at this particular location. That means the center of the structure should divide this particular distance equally. That means the center of the structure should divide this particular distance equally, right? In this way you have to put it. So let us consider this is P2, this is CG, this is P1, this is P2, this is P1. So this distance will be what? Z2 by 2. This distance is also Z2 by 2. This one is basically Z1. So our absolute maximum bending moment will occur below P2. Absolute maximum bending moment below P2. Getting a point? So this is the most frequently asked case in the GATE examination. And this should be the ILD which you have to draw, and kindly find out the ordinate below it so that you are able to find out the absolute maximum bending moment. Getting a point or not? Very easy. Are you able to recall it? हाँ 20 मिनट फ्रेश हो जाएगा सर. Must be have good. No, Praveen, sometime it, let me tell you the truth. In some of the method, we need a good command in the integration and the, you can say that derivative part, right? Or differentiation. But let us suppose if you have moment distribution method, if you have like slope deflection method, I'm telling you about the slope deflection method which we have used in our structure analysis. And ILD part, right? And like arches, not arches, you can call, means consider cable, right? So some of the chapter in which you don't require such type of things like integration and derivative part, but in some of the chapter it is must, like strain energy method. If we consider arches, no doubt we required this particular thing. In matrix method it is not required. Again, in matrix method is also simple, right? Like static intimacy in stability portion, they, in that portion also you don't have to require like differentiation and integration. So you can say that like 60-40, you can say that in some of the chapter we required it, and in some of the chapter it is not required, right? Not completely. Okay, I will close it. No problem. Okay, so are you able to understand this case, all of you? Then we'll start the matrix method. Okay, Praveen. Done. So this is the most important case which you have to remember, right? This is the most important case which you have to remember. Now I think all of you know that how to find out the ordinate, how to calculate it. Last thing guys, which is we want to discuss over here, that is basically matrix method. So in matrix method, I will tell you certain things which is very, very important, and then we will close it. Okay, listen guys. But matrix method again guys, least important chapter as per the GATE point of view, least important. Now let me explain it. Matrix method. If we talk about matrix method, there are two approach. One is flexibility matrix method. Second is stiffness matrix method. Flexibility matrix method we have to use when the static indeterminacy is less than kinematic indeterminacy. Then only we have to use it. But in case of stiffness matrix method, when the kinematic indeterminacy is less than static indeterminacy, right? Understood? Getting a point? And this particular method is a force method, and this method is a displacement method. This method is displacement method. Now guys, what are the things which we have to understand if you want to understand the matrix method guys? So what is stiffness and flexibility, coordinate direction, primary structure, property of stiffness and flexibility matrix, how to develop it, and this part is not important. Why? Because it is a complete solution of a structure, which is not possible in 2-mark question, right? Now guys, as we have already know what is basically stiffness, this particular part we have discussed. Now the question is, what is flexibility? What is flexibility? So flexibility is nothing as it is the displacement caused by unit force. What it means actually, let me show you that. Let us suppose this is a spring. If I apply certain force F, so we can write here F is equal to K into X. So how much displacement is caused by unit force? That means F is equal to 1. Then X is equal to how much? 1 by K, right? And this 1 by K is nothing as our flexibility. Getting a point? So what is the value of displacement which can be caused by unit force is known as flexibility. So tell me guys, if you have a rubber band that is more flexible or this pen is more flexible, tell me guys. We'll close it hardly in 10 minutes, right? Tell me guys. Rubber band is more flexible or this pen is more flexible? Rubber band. Why? If you give some force, then it may have more displacement, right? If you give unit force, then it may have more displacement, but this pen will have very least displacement. So this is more stiffer, less flexibility, but that rubber band is more flexible, less stiffness. Clear? Okay. Now guys, the coordinate direction and the primary structure, very simple. Listen guys, there are two approach. One is flexibility matrix. So in case of flexibility matrix, the coordinate direction, number of coordinate direction, please remember it. Number of coordinate direction is equal to ds, right? Is equal to ds. So let's understand. Let us suppose this is a structure which is given to us, and I want to draw the coordinate direction and the primary structure. So how many coordinate direction are there? It will depend upon the static intimacy. So for this structure, static intimacy is equal to how much? 3. Getting a point? So any three direction you have to consider, as a coordinate direction, but our structure should be determinate and stable. In this case, right now it is indeterminate and stable. But after considering those three reactions, again our structure should remain determinate and stable, right? So let us suppose these three reactions we are considering as an unknown. So kindly remove it. After removing it, you need to draw the direction, coordinate direction, like direction 1, direction 2, and this is direction 3. So what is this? This is basically our primary structure. Clear? And this one is determinate and stable. Determinate and stable. Getting a point? Easy. In case of in case of stiffness matrix method, stiffness matrix method, in case of stiffness matrix method, the number of coordinate direction will depend upon dk, right? So let us suppose if you have a cantilever beam, and in this case dk is equal to 3, right? So the 3 coordinate direction should be represented as it is. So in this case you don't have to change the support condition, right? In this case we don't have to change the support condition, our support condition will remain same. But in case of flexibility matrix method, we have to change it, and this is our primary structure. 1, 2, 3. Getting a point? For ESC practice PYQ is enough. Yes, we can consider this, but Praveen, it is my suggestion, kindly use the test series also and try to make or try to use that particular practice, that means test series questions, right? In your notebook you have to write it down sometime, like some of the doubts are there, some of the questions which we are not able to solve. So kindly use those questions and make a notes separately so that you can understand these are the topic which I want to fill, so that my practice as well as my knowledge will become more stronger, or you can say that it will be increase, right? So that is my suggestion. Okay, now guys, the last thing which I want to explain over here is property. What is the property of stiffness matrix and the flexibility matrix? Please remember, it is always a square matrix. Diagonal element are always positive and non-zero. It is always positive. What it means actually, let me show you that. Let us suppose this is our flexibility matrix 2 cross 2. So this one is F11, F12, F21 and F22. So these are the diagonal element. So these diagonal element are always positive and non-zero. And this is a square matrix, and diagonally opposite element are always same in magnitude and same in sign. If it is negative, then this is also negative. If it is positive, then this is also positive. Clear? So guys, these are the things which we want to discuss. Now the next thing is basically how to draw or how to develop the flexibility and the stiffness matrix, that you can learn, right? Or just you have to revise by yourself. Kindly revise it. Okay, that is the only part which I am giving you as a homework. Kindly revise it, how to develop the flexibility matrix and the stiffness matrix. Okay, kindly revise it by using one question, and the rest of the thing we have already discussed, right? So if you have any doubt, any question guys, you can ask me right now. And that is the thing which we want to discuss in our part of marathon. Can you do it guys? Can you do it? How to develop flexibility and the stiffness matrix? Can you do it? Just you have to revise a single thing, right? By your own. Yes, okay, sure. So let's close the session guys and let's take a break. Okay, and tomorrow I think we have one MCQ practice question, right? 100 questions are there, in which I will take the structure, RCC and mechanics part. So kindly join that particular test tomorrow guys, and I think all the faculty will be there to take this particular test, and I think it will be much beneficial for all of you. If you want to do the practice, you can come over there and do it. Okay, so thank you so much guys. Let's meet in the some other session, and I hope this particular session will give you a quick revision for your GATE examination for important part of the chapter, right? But guys, no doubt if you want to learn the subject, no doubt it will like be a 60 or 50 or subjects approximately minimum, right? Then only you are able to cover it completely. Otherwise guys, in a 10-hour duration we are just able to revise the concept. Those who have already covered the subject, then it will be much beneficial for those students, right? Getting a point? Okay, so thank you so much guys. Let's close the session, and I think already we have done it. like 4 are right now over here and 4 are before, right? So let's close it and let's meet in the next session, guys. Thank you so much, guys. Bye bye, take care and good day. Thank you, Arun. Good night, Arun. Grish, thank you so much. Swapnil, thank you so much. Ashish, Tikshas, thank you so much, बच्चा लोग. Okay, Praveen, thank you so much. Okay, Prashant, thank you so much. Let's close it.